Dynamics, and I know Alta and others that are with us today. So I really want to thank those sponsors. Our planning committee too, which are here, Lisa and Jaleesa and Norm, everybody who's Evan helped out with all the Zoom functionality we have. So it's been a real teamwork to make it happen. So. Leading into our first panel, when we were talking about doing this, we put together two panels, one focused on training and education, one more focused on data quality, sharing, collaboration, that type of thing. And we thought it'd be a good opportunity to get some people who have been around since the first GIS day doing GIS and talk about things that have been transformative up till now, and then maybe look forward and maybe from their wisdom, see what we can gain looking to the next coming decades. So with that, we're gonna have a panel in the morning, panel in the afternoon, short talks interspersed. For folks here in the room, there is a raffle at lunchtime where we'll have subs and other things. So if you need the QR code for the raffle, it's on the tables or out front. And if you need Wi-Fi also for guests here, that's available too under Vandal Guests. So I'll step out of the way and let our first panel get underway and let them introduce themselves and our moderator for the next hour.
Good.
There's 3 chairs and 2 of us. Oh, man.
Welcome again. This first panel, we're going to talk about GIS education, kind of how we started in GIS compared to how education is now. We're going to look at kind of the training, what GIS training was like, and how it has impacted our career growth. All of us have been in GIS for the past 20 years or more. First, my name is Ed DeYoung. I have GIShelp.com as my current consulting and training company. I have worked in GIS for over 25 years. I was an adjunct here at U of I on the Coeur d'Alene campus for over 12 years, teaching the GIS certificate through the geography department at that time. Then I got my dream job teaching GIS full-time. I did that at Boise State for 4 years, and then left Boise to come back to here, and now have been working on as a consultant doing my own training and GIS consulting. So right now I'll have each of the panelists introduce themselves. You want to start, Frank?
Sure.
Since you're the furthest from me, you can start.
Sure, that's great. My name's Frank Roberts. I am currently a global data architect at Mission Aviation Fellowship, but prior to that, I ran the IT GIS group at a consulting group called Innovate Inc. And then prior to that, I spent 20 years at the Coeur d'Alene Indian Tribe. So I've got to have a really long experience of years. My uncle introduced me to GIS when I was in forestry school, and he worked for a small forestry group in Western Washington. He said, "You should learn this GIS mapping thing." And I was like an 18 or 19-year-old kid at the time. And I was like, "Oh, okay, cool." And so that began my entry into it, and little did I know, like almost 40 years later, I'd still be doing GIS stuff. And it's been an absolutely amazing career. I see people from the Coeur d'Alene tribe that I've worked with and just had a lot of really great opportunities. Just a handful of things, because you said I got to have 5 minutes, so I'll blab for a little bit.
Yeah, go ahead.
I'm the oldest dude in the room apparently, which is super weird. I mean, I see some key things in GIS education that has really changed over the years. Kind of like 3 parts of a stool in GIS education. The first is really the hardware part of GIS. So like when I joined the Coeur d'Alene Indian Tribe, they decided they wanted to get into some GIS, and we needed to buy a SunSpark workstation to do GIS, to have a computer to do GIS on. And at the time, I had just purchased a house outside of Princeton, Idaho, on the backside of Moscow Mountain. And that house cost me the same amount as we spent for the SunSpark workstation at the Coeur d'Alene Tribe. Like,
I made that exact same comparison when we got our first SunSpark.
crazy. Like, can you imagine? I mean, think about that in this. I don't know what a house goes for on the backside of Moscow Mountain this day and age. I Googled my house I bought. I think it's $450,000 or something. And like, could you imagine going to your boss and saying, yeah, I want to do this mapping thing. Can I get like $500,000 to buy a computer to do it on? Like, that's insanity. And now we kind of flash forward to today, and like literally you can go down to Walmart and buy a computer that has a decent graphics card and 16 gigs of memory in it for like $500-600. So like the opportunity we have in this day and age is amazing compared to what we had then. I think the other leg of that stool is like some kind of GIS platform. There really wasn't a whole lot of choices when we were first doing the GIS stuff. I'm just like grass. There was this like ArcInfo thing, and there was like a couple other little oddball things out there. And now just in the Esri suite alone, there's like 80 to 100 modules of different GIS things that just the Esri package does, not including all the open source and all that kind of stuff. So lots of opportunities of things to learn about. And then kind of the last part of that stool in my head is the training. Like, how do you learn this thing? And at the time, literally, I was so happy that Bruce found the picture. When you bought ArcInfo, you literally got a 4x4 bookshelf with books, because that was the help document. You got these 3-ring binders, and occasionally they would release more notes or something that you could put in the binders. And you had to just pour through these stupid books for hours and hours to learn how to print or edit a map. And now you can just go to Google, look for a YouTube video, and some nice person like Keith or somebody has made a video of how to do these things, and we have lots of great instruction in the state. So I think those are the big changes that I've seen in my career, and I think it's just amazing to see the opportunities we have now. So.
Yeah, I agree. Thanks, Frank. And then the third seat is Keith Weber, who is coming to us remotely. Keith, you want to introduce yourself, please?
Yeah, certainly. I'm going to
You have to unmute yourself, I believe.
yeah, I should be unmuted. Can you hear me, guys?
But we don't hear him.
You can't hear me? Let's see. Can you hear me now? Can you hear me now? Well, that's not good. Oh, they can hear me on Zoom, but not in your room.
We got him a little bit now.
Do you want, let me disconnect and then I'll reconnect. And maybe if you want to go to the other person to introduce himself, okay?
All right, well, we're trying to do that. Then Jason, why don't you introduce yourself?
Yeah, sure. Hello, everybody. My name's Jason Carl. I'm a professor of rangeland ecology in the College of Natural Resources here at the University of Idaho. And I started my career in GIS here at the University of Idaho as an undergraduate student. I came here in 1992, and my experience mirrors a lot of Frank's experience. We had SunSpark workstations in the GIS lab that I worked in here. We had these old, they were state-of-the-art SCSI external hard drives that were 1 gigabyte drives, and they were each about the size of a toaster. They sounded like a jet engine when they spun up. And I can remember we were doing the first statewide land cover map for Idaho at the time. And to load the Landsat satellite images, we actually had to remove software from the computer. So we had enough space to load a single Landsat image on the computer at the time. So yeah, and then the other big thing to me that has really changed in I don't know however many years that's been now, 30 years, is the training piece. Because when I was an undergraduate student here, GIS classes were restricted to geography and landscape architecture. So I was never actually able to take a GIS class. And so I had an apprenticeship model for GIS at that point. So Dr. Ava Strand is the one who taught me GIS out of those manuals, right? Out of the ARC info manuals. Bruce had a picture, or somebody had a picture of the old ARC macro language, AML manual up there. I wrote my entire master's thesis research in AML, right? So yeah, so it's come a really long way in that time, just the diversity of applications that are available. But I keep coming back to the fact that a lot of the core concepts are still the same. You know, we still do the same basic GIS operations. You still have to know about coordinate systems and projections, right, in order to be successful. So the basics are the same. Maybe how we get there in the end is a little bit different. So.
Yeah, thank you. Thank you, Jason. Let's try introducing Keith again. See if the sound works this time.
Yeah, can you hear me now?
Yeah, that's great. Thanks.
Oh, amazing. Amazing how this technology is today, huh? Wow. Hey, can I share my screen?
Sure, go ahead.
Let's see if I can. Host isn't allowing multiple presenters. Okay, I'm not going to worry about it. Okay, so let me just introduce myself. I've been involved in GIS, part of the GIS field, the profession, since 1988. I founded Idaho State University's GIS Center in 1999, so 10 years after I kind of got started there. And I actually taught the first GIS course at ISU in 1998. Later on, developed the geotechnologies program here at ISU that contains right now an undergraduate minor, graduate certificate, Master of Science in Geographic Information Science, as well as emphasis areas for PhD programs. I'm currently teaching. I don't teach too many classes anymore. I focus on spatial research, but I am currently teaching information technology for GIS, teaching workshops, and I'm mentoring internships as well. As I said, I now focus on my research, or focus on research here at the GIS Training and Research Center. And our research program is focused on temporal land cover change in semi-arid ecosystems. Much of Idaho is in that semi-arid ecosystem. And we look at, why are things changing? And approximately, we see that that's because of wildfire, invasive plants, and land management decisions. And it's been, it's been literally decades that we've been looking at this, and it's not too difficult with good satellite imagery to detect change. That's the easy part. But understanding why things are changing, how they're changing, and how they might change in the future, that's really the exciting stuff. I've been fortunate enough to have almost continuous funding support from NASA, support also more recently from FEMA, the Department of Interior, National Science Foundation, and other numerous organizations, agencies. Today, we have tremendous effort on wildfires and disaster response here at the GIS Training and Research Center. Part of that is our very large NASA Recover post-wildfire decision support system. We have a new wildfire project funded by FEMA looking at pre-fire risk, wildfire risk, principally working with emergency managers in eastern Idaho. We've done a tremendous amount of work over the years and continue to do this work with LIDAR, and the NASA Develop Capacity Building Program. Now, in my perspective, we talk about GIS education, training, and teaching, and I emphasize a difference in training versus teaching. But you know, when I was a student, just like some of our other panelists, I could not get a degree in GIS. Oh, I was allowed to take classes. I took every class that existed, and there wasn't many at the University of Wisconsin. There was 2 actual classes plus an internship, so I did all that. The most transformative changes over the past 25 years. That was one of the questions we were asked to mull over. And number one, I would say it's new technologies. Some of the things I've already alluded to, you know, the satellite imagery, the availability of satellite imagery. We used to have to pay for that Landsat. We can now download it. We can bulk download it. We've got Landsat, used to have Spot, now we have Sentinel-1 and 2. We have commercial satellite imagery, and of course, aerial imagery and UAS. So the resolution of our data has changed dramatically, and I mean the spatial resolution, the temporal resolution, as well as the radiometric resolution. Landsat has changed quite a bit, even in that sense. It has gotten more radiometrically resolved. And look at the internet. You know, when we first started all this stuff, we didn't have an internet, right? I mean, it was in its infancy, and we never even imagined about drawing a map or trying to draw a map on the internet. So now we have web services, we have the Internet of Things. We can pull into our GIS, our maps, our web maps. We see the proliferation of GIS and spatial data that's being used all over the place. People don't even realize their use of spatial data. And then another very transformative change over the past years literally was COVID. You know, it has changed a lot of people's lives. And it also changed kind of how we do things. Look what we're doing today. We are doing so much more online, webinars, web meetings, online meetings, all these sorts of things. And so maybe that's the silver lining behind the COVID cloud, but that, without a doubt, is also very, very transformative over the past 25 years.
Well, thanks, Keith. The next section, we're going to spend about 20 minutes with questions that I'm going to ask the panelists, and we're going to discuss some of those questions for 20 minutes. And then after that, we got 15 minutes for you to ask questions of the group, myself and the panelists. So the first question we're going to discuss is, what are some of the future trends in modern GIS education, training, and service? So what's the direction that we're going? Who would like to start on that?
available to them. The other thing, and I was reflecting on this the other day, is I think that the era of the GIS lab is either gone or fading, right? And when we look at, like, we have the geospatial lab in the basement of the CNR building, fewer and fewer classes are actually using that lab space because we don't need to use that lab space, right? We have inexpensive computers that we can get, wherever that can handle this sort of processing. I teach the digital photogrammetry class, the drone mapping class, and students just use their own laptops for that. So modern computing hardware is able to keep up with these requirements for, I think, the teaching and training purposes, which is in some sense kind of democratizing their access to this learning material. So,
Yeah, well, and another trend that has changed is when we started, there was no textbook on GIS.
Yeah.
There was one program by the federal government, someone trying to raise teachers and curriculum when I started. And now you can find dozens, if not hundreds, of introduction books and textbooks on GIS. So now now the choice is a little bit harder. First, it was like, how do you find any information? Now there's so much information, which one's the best one to fit what you're trying to learn. So it's kind of a big change. We'll go on to the second question. The second question is, what disconnects do you see between what academic GIS curriculum includes, such as in degrees or certificates, and what employers are looking for? So what's the gap between education and between actual working? Frank?
I'd love to take a stab at this one. So in my prior job at Innovate Inc., that's where I worked for about 12 or 15 years. And we were a GIS consultancy for the most part, and had upwards and, 100 staff working with me doing GIS stuff for USGS, for the Forest Service, for Department of Interior, for the Army, Air Force, and then other organizations. And my number one barrier to growth at my organization was getting skilled employees to come work for me at the company. And a lot of that was, I think there's kind of, oh, thank you. Sorry about that. And so that number one barrier was getting skilled individuals. And I would repeatedly meet with local universities in different forms and formats to try to get kind of the folks we need. And the biggest demand, I think there's kind of the introductory GIS analyst, GIS technician. I think the schools are doing a great job of kind of churning out those sort of folk. But in the consulting industry, lots of times the folks we work for, they already have those skills, and they need somebody that can develop a JavaScript API map or a custom thingamajiggo for Survey 123 or something like that. And trying to find people with those skills and building those skills was a real challenge for our organization to find those folks.
do you think, can I ask a follow-up?
Yeah, go ahead.
Do you think, Frank, that the certificate programs were adequately preparing the students for like real world work, or was it just like the certificate means that you can spell GIS, right? Like,
my interpretation, because people would come to us and like the Department of Interior or USGS, and they would say, we need a GIS person to do X, Y, and Z. And never in any of those conversations in 15 years did they say, and they need a GISP. That was never a requirement of what they were looking for. Can the person do Python? That was. Can they know how to work with a SQL Server, enterprise geodatabase? Yes, that was. But I think that maybe gets you in the door for your first job, but I didn't personally witness that being a barrier to entry if they did or did not have a GISP.
Yeah, and my experience, I've been both in consulting and working in GIS and in training GIS. And I hired lots of people from U of I with their certificate. And what we found, what my found was that with the certificate, they were good to start. but it took between 1 and 2 years before they became really productive. So they really knew GIS. And I think kind of the problem with that is in getting a GIS certificate, you have lots of practice with clean data. You have lots of practice with things that go smoothly. And when you get outside of education, outside of academics, nothing is clean, nothing works smoothly. So you have to figure out all those little things of how to make it work, how to clean the data. And so that's kind of, if you have a certificate from a good certificate program, you still need to have experience to know what you're doing and to be able to fit in productively in the job.
And by all means, I'm not saying it's not worthwhile to get a GISP. I'm just saying that wasn't a barrier to entry, so.
Yeah, I agree too. But you have to learn somewhere, and so a certificate is a good place to start.
Absolutely.
Let's move on to the third question, which talks about the GISP. If you don't know that, that's the GIS professional certification that you can get. So it says, what do you look for when evaluating a GIS certification? GISP certification, vendor certification, Esri's technical certification, UAS pilot certification. So those are just some of the certifications you can get. And now the GISP, the GIS professional certification, has come up with a new program called the pre-GISP, so that if you graduate from the university with a certificate or a degree in GIS, then you can take this pre-GISP, get into that program to, I imagine, to then become a full GISP at some point in time. So that the GIS professional organization just came out with that new program to get more people into it, I think. Either of you want to look, dig further on that questions of the
Keith there still?
certificate? Yeah, it looks like he's back now.
Let me jump on this one.
Great.
Number one, I think that GISP is good. Again, I haven't seen any instance when we ever listed it as a requirement for a job opening here. However, if a person has a GISP, we certainly didn't, detract from their qualifications. It was a plus without a doubt. And I know that a lot of folks use the word certificate and certification almost synonymously, but there is a difference. A university can provide or award a certificate. That means simply that you've completed X number of courses, and normally it falls short of a full degree program, bachelor's degree or something like that, in the total number of credits. But a certificate is also very, very focused. Here at ISU, the geotech, as we call it, geotech certificate is 19 credits, but every one of those 19 credits are taken at the graduate level, and they are focused on GIS or spatial technologies, those sorts of things. Now, an organization like EURISA or actually GISI can provide the certification. That's almost like an accreditation body that says you have the skills necessary to be considered a GIS professional. So I think that's good. I think it certainly served its role to take GIS. When I first got my very first job in GIS, it was with the Wisconsin Department of Natural Resources, and my job title was an MIS specialist. M, not G. And I that was a management information system specialist. And I asked them about that. Why, all I was doing was GIS, ArcInfo, command line. And I asked them about that. And they said, well, the state of Wisconsin doesn't want to create a new job title for a fad that's going to go away in a few years. So we're not going to create a GIS specialist. We just kind of put it together with this. Well, they were kind of wrong, right? But then, we progressed and GIS became much more prominent. We started seeing GIS like all over the place, not like it is today, but still, it certainly grew, it matured. And then GISP said, you know, we really need to make this into a recognized profession. And it certainly did that. I think it helped jump that step, lift us up onto that next step, recognize or recognition as this is a profession. And now that we're there, you know, maybe now it's not so important to have that, but I think it was necessary to make that next step. So certification, that's my take on it.
Yeah, very good. Let's jump to the next question. And actually, I'm going to combine the next two questions that I have. So one question is, what specific skills are required to be proficient in GIS and GIS-related technologies in the coming years? And the next one is, what advice can you recommend the audience to continue their learning in GIS? So what's coming and how do we get there is kind of the question as far as GIS technology. Who would like to start with that one?
You look at
Sure,
me.
sure, either way.
Go ahead.
I can kick it off and you guys finish the holes behind me. I mean, I think specific skills required to be proficient in GIS, some of that is just experience. Like go in and get your hands dirty. Like part of our interviewing process at Innovate was to provide, after somebody we said, oh, they seem like a nice individual, they smile, they don't seem like jerks to work with. Cool. First box checked, but can they actually do the task? And then so we would do a skills test. And it wouldn't be it wasn't like the impossible skills test. It was half an hour and, hey, can you add this layer to the map? Can you change the color? Can you query the database? Can you do some simple statistical stuff? And maybe a few other things. And just having people work through that and then understanding the problem solving skills, because we would give them more than they could do intentionally. So then they would have to figure out how to prioritize what they're going to do on this list. And are they going to get wrapped around the axle like has happened to all of us in the GIS industry, I think, where you just beat your head against the monitor for hours. And it's like, you know, that kind of learning thing, I think, is a really important process. And also, I think just the human part of it, of saying, you know what? I don't know how to do this. Can I skip to the next question or whatever? That being transparent and things like that, I think are really, really important things. I don't know if those are specific skills, like it's not saying go out and learn Python 3 or whatever it is, or JavaScript API version, whatever. But I think that ability to learn and to work with people is a really, really valuable skill, because typically we're facilitating other people as GIS folks. We're facilitating foresters or fisheries folks or landscape architects. We're the geeky guy in the basement with the red stapler, kind of.
All right.
So,
Yeah.
my opinion, take it for what's worth.
I think another piece to that is almost a personality trait, because it's so important to pursue continuing education, becoming that lifelong learner. If any one of us came into this and said, okay, I got my degree, I am now an expert at GIS. I hate that word, right? Because oftentimes people say that, and that means I do not need to learn anymore. But in this field, wow, you will be left in the dust in year, 2 years, 3 years for sure, right? So that's just so important, and that I think is a personality trait, that willingness to learn new things, be able to learn new things, jump on new things. Don't have to be at the bleeding edge of things all the time. But I think that's important. And I always encourage students, whether they're, you know, traditional semester-based students sitting in my classes week after week, or they're with me for a day on a workshop, I tell people to engage, right? Don't just go through the motions and, okay, you sort of completed things. Engage, ask those questions. That's super important. I tell people, get your money's worth, right? You paid for it. Ask those questions, get everything that you need out of this, and make what I'm trying to teach you, make it part of your knowledge by the end of the day or something like that.
If I can just sort of add two additional things there. to me, I would say one is focus on concepts, not software. And that, you know, the basic theory, the basic sort of operations premises of GIS are the same, right? I mean, we've continued to sort of innovate and develop some new technology or new techniques, right? But if you look at, like, you know, I started on ArcInfo 5, right? Like, that doesn't exist anymore, right? Like, I wrote my thesis in AML, that doesn't exist anymore. The thing that I learned after AML doesn't exist anymore, right? And so, like, you have to keep sort of like learning new things, but the concepts are the same, right? So if you understand the concepts and how to sort of apply those concepts, then you can figure out the software applications that you need to. Now, at some point, I'm gonna decide I'm too old to learn the new thing, right? And then I'll just retire and do something else with my time, but the concepts are the same. And then the other thing I think that goes along with that is that GIS as a science, or GIS even as a thing, doesn't exist without data. And so if you're gonna invest in really learning something and knowing like something back and forth, I would say learn data and data structures. And that's gonna help you solve all of these problems with messy data, right? And the real world problems of like, how come my layers don't line up against each other, right? And so if you understand data and how they're stored and how they are sort of represented in the different applications, then I think you're gonna be well set to teach yourself moving forward.
Yeah, I agree completely. When I was teaching students and they're in labs and they'd ask me questions like, why doesn't this look right? And I would do, that's the first question I always ask them back is, what does your data say? So look back at your attribute table and that will tell you what's wrong with your map. You know, so lots of times it's your data that will tell you what's wrong. Let's go on to the next question. Participation in GIS working groups, committees, that has been a hallmark of the statewide GIS efforts in Idaho. What is the biggest challenge facing us related to the service to the profession of that sort of thing going forward?
I'll jump on that one to start while other folks may be thinking about it.
Sure.
If that's okay. And it's recruiting, right? That is so difficult, recruiting that next generation. I think things have changed. You guys have noticed this, right? I'm sure everyone has noticed it. Things have changed in the job market. Things have changed in the workplace. A lot of that, I think, was really punctuated because of COVID. Things were starting to change before that, no doubt about it. But yeah, how do we engage that next generation? How do we recruit them, convince them that volunteering some of their time is actually worthwhile, worth something? I had a discussion with some students about this, and they were very frank about it, very honest, I guess, about it. And some of them, not all of them, but some of them said, how much am I going to get paid for doing this? You know, kind of what's in it for me? Nothing extra. What can I say? There is nothing extra for volunteering. But, you know, I think a lot of the new generation, I'm not going to say that they're entirely wrong. What they're faced with is, look how expensive your house has become, Frank, right? Someone's going to try to buy that on this wage. They talk about, give me a livable wage. Why should I work more than this time, 8 hours, and then do more, right? I need to go do this. I need to go do that. That's difficult. It's extremely difficult. It's broader than just GIS, obviously, but still trying to engage and recruit some of that next generation because, you know, Jason, you said it too, we're not going to be here forever. When we end up retiring, we need to have that next generation there to give their ideas, provide their input, and steer at least Idaho in the big statewide enterprise efforts.
Just follow that and say, this is not a problem that's unique to GIS. We're seeing it in all sorts of professions, like the Society for Range Management or the other sort of, range management professions that I sort of operate in. And a big issue that we've identified there is that employers, especially the federal agencies, are not, they don't see the value in participation in these efforts, right? So they're not prioritizing it. They're not encouraging their employees to participate in these things. And so I think there's an opportunity there to sort of work with employers and agencies to sort of restate the value of these professional societies and what participation in those means. But short of that, I think what you're left with is just a very small set of people who sort of feel that altruistic pull to sort of contribute to something beyond just their work and the thing that they have to get done so they can get their paycheck. So.
Yeah, maybe just to wrap that up, I mean, I think there is some onus on us, the employees. I mean, I think it's important, like, I'm pretty happy that my boss at MAF let me drive the 3 hours from Sandpoint down to here today and drive home, and I am gonna get paid today, right? But that's cool. But I think every place I've worked, I've had to, emphasize with my employer, hey, there's this working group, there's other people there, they're a lot smarter than me, I'll probably learn some things from them, and the value that I'll get from attending the working group or being on the committee will better me and this organization. And I think using that kind of line of thinking, I've got to do all kinds of crazy stuff. I mean, I got to sit on a National Academy of the Sciences committee in Washington, D.C. on parcels as the token tribal guy, which is kind of funny. I mean, I got to go to Africa while I was on the dime for the Coeur d'Alene tribe and teach classes with the Smithsonian Institute, all because of, I mean, I had very gracious employers, but I also had to kind of pitch it to my employers, well, why would you want to have him do that? So, and I think, those are opportunities that we have to kind of take and pitch.
Yeah, thank you. We'll go on to the last question from me, and then we'll move after that to your question. So the last question I have is, what have you learned due to your work experience in GIS that you couldn't just look up on the internet?
Go ahead, Keith.
Yeah, I know. You guys saw my hand moving toward my butt. Right on. I saw these questions, so I jotted myself a few notes in prep for this. What I've learned is there's this real special dynamic of people and groups that you can do a search on the best AI chat bot or whatever the heck, and you'll get a canned, nice answer. But when you get X number of people in a room that have various, they're all GISers, but they have various backgrounds and perspectives. Their paradigm is all slightly different, and sometimes they have different goals that they'd like to see GIS move toward. And that really is how GIS at a state level, the federal levels, these larger levels, how they really evolve, right? Certainly we can't do anything without data, and we want the best of data. We want great data. We've got to have that. We kind of have that. Here in America, we are data rich, right? But then when we start talking bigger picture, data governance, standards, wow, standards are so important, right? That's when the people come into it, and the dynamics of those people in those groups really change and makes Idaho's data what it is, and you go to another state and things are different. So what do you guys think? Jason, Frank?
I just thinking about like things that I don't know, my experience and like what you can't get off the internet. And I guess I've sort of thought about this, like in my mind, GIS is like 20% about knowing how to do something and 80% about knowing whether you should. And that's the kind of thing that the internet is never going to tell you, right? Like, yes, you can do this operation, but your data don't support this, right? Like your data are not of the quality to do this thing that you want to do with it, right? Like that's something that only comes through hard knocks, I think. I think the other thing too is, so like being a professor, academia is act 3 of my career, right? Act 1, I was a GIS analyst for nonprofit organizations. I did production cartography work for like 10 years, and then I was a federal research scientist, and then I came here, right? And so I think one of the things that sort of first part of my career taught me is just the need to always question the result that you get, right? And just make sure that you have confidence in the thing that operation produced for you, right? Because it's so easy to just run something and then, run with that result, right? And get yourself in trouble down the road. So I think that's probably, the piece to me that you can't look up on the internet. Although Stack Overflow is really great, like for figuring out why something doesn't work, right? It's fantastic, but.
Yeah, absolutely. I mean, the two things that I jotted down quickly is, so my second favorite website is a website called Zombocom. None of you probably know of this website, but you should turn your speakers on and listen to it, not right now. But it speaks to like the infinite ability of this site to do anything and everything. And I think sometimes we go into GIS software, or you get the privilege to go to the ESRI Users Conference with 20,000 other GIS geeks, and you believe that the software truly can do anything, and that's not the truth. Like, there are limitations. There's limitations of hardware, there's limitations of software, and it all doesn't actually work just like it works on the stage at Redlands or wherever you're at. So I think understanding and not over-delivering is an important thing to the community around you. The other thing that I think I've noticed is in organizations in general, or humans in general, seem to have a very, very high pain tolerance. Like, they will do crazy, bizarre things that take a really long time, that are painful, and they will just keep doing them over and over and over again because that's the way they've always done them. And so I think in many cases, at least in the folks I've worked with, I'm like, can I just like make an easy button for you to just like click that instead of take that thing that takes like 2 weeks to do? And so, and I think those quick wins, and people are like, oh, like, you've given me a week of my life back. Those things have really sold GIS in the organizations that I've got the opportunities to work with. And I think there's a lot of things that we all can enable people to do to make their lives a little bit better.
And Jason, you said one thing earlier that you can look up on the internet and find, how to do something, but it doesn't tell you what you shouldn't do. And I thought you were going to go in a little bit different direction, but I'm going to throw this out. And I think that we do need to think about this as teachers, as GIS community, and what you're not going to see also on the internet is what you shouldn't do. But that's what Jason said. But what I'm driving toward is the ethics of it, right? Because years ago when we first started, and people talked about misuse of geospatial data, privacy issues, and I'm like, if I zoom up on a Landsat pixel, it's 30 meters, it's it's almost 100 feet on a side. I can't see a person's car and their license plate and whether they built an addition onto their home. Yeah, sure. I'm not too worried about violating privacy with GIS. But now fast forward, right? And that is one thing that I do talk a lot about to my students in information technology for GIS classes. This extremely highly spatially resolved data, temporally resolved data, real-time data that as a GIS profession, we need to start, I think we need to start, maybe should have been a while ago, seriously thinking about, should we do that? So it's a little bit different, should we do that, than what you said, Jason, but I think it should be said today also.
I agree completely.
Yeah, thank you. All right, now we've finished the questions I have. And so if you have questions, please let us know, and you can direct them to me and I can forward them to the group, or you can do it to a specific person. And also, if you're on Zoom, you can also submit a question as well. Yeah, sure, go ahead.
I was just wondering about, geography has always required data. You said that. So I wanted to talk.
Hold on a second. Let me grab the mic so people online can hear you. Sorry. Just make sure the online people can hear.
Thank you. Geography has always required data, and some of you said that during the Q&A part. So I, wanted to ask about computer science and kind of intruding on geography. We've always been in kind of an interdisciplinary discipline, right? We've done forestry and economics and urban planning and all of these things. And with kind of the proliferation of programming languages, especially R, it's almost anybody can program spatially now. So how can we, as geographers and GIS users, kind of protect ourselves going forward and retain our principles and theories that make us unique, while including people in like computer science? Because I've seen too many examples of people in computer science that can program spatially and do really good geocomputation, but they really lack the geographic knowledge and theory to complement that. So how can we kind of insulate ourselves as a discipline, and how can we better, I guess, promote geography and geographic principles across disciplines, especially computer science? Thank you.
You want to take that first? Yeah.
No one wants to touch that?
I don't know.
I have thoughts.
I have
but-
thoughts too, but I'm trying to compose them in my brain right now. I have a story. Can I tell a story?
Go ahead. It's
Let
story
me tell a
time with
story,
Frank.
and I think it gets a little bit at what you're at. So when I was at Innovate Inc., we got a phone call from a rather big and fancy health analytics organization, a very, very big one, who hired another very, very big computer, multinational, gigantic IT house. And they had these nice gentlemen who happen to live in India build them a tool. And I'm pretty sure these nice fellows in India, they're all good folks, they didn't use the right building blocks. And they were really, really confused after spending millions of dollars, maybe, why it doesn't work. And I think that's kind of maybe some of what you're driving at. It wasn't that they were stupid folks. They were very smart folks, and they had degrees and all that fancy stuff that you get at universities and stuff. But they built a tool that was essentially unfunctional. And so they brought me into the room. They brought some fancy guys from Esri into the room. And I'm no longer an Esri business partner, so I can say this. The guys at Esri just wanted to sell them a new piece of software. Well, we have this new piece of software. It just came out last week, and it's really cool. It'll solve all your problems. So I'm looking at it as a GIS person saying, no, you just used the wrong programming building blocks to do this. I know why you can't get the data back. And it was that based, like the geography information that we all get from getting our degrees here and working with projects that help me understand the direction to help this client go and to help them use the correct building blocks. So that's the story that I have in relation to that.
Yeah, we see that, don't we? We see that a fair amount. In fact, there's a certain tool in a certain piece of software that what it is we're telling the software to take a point location, geographic point, and if you know points, they don't have any area, right? It is a point on the ground. And we're dropping it onto a raster pixel, okay? And we're telling the software to tell me what is the value of that pixel at that point. Well, there's an option we can turn on that says interpolate the value at this point. That is thinking that that point somehow falls onto two different pixels. But if you know geography and you know points, lines, and polygons, a point cannot fall onto 2 pixels, right? So you see that and it's like, oh, gee, the programmer on this pretty big piece of software doesn't really understand geography. They did a whiz-bang job on putting together the software, but they don't understand geography. That's really bad. Now, the flip side of that is it would be great to see more geography folks coming out of our own degrees here that know how to program. So we do offer a couple of different programming and GIS classes, but I think the programming we're looking at there is not so much the scripting programming of Python and whatever, but probably more along the lines of C, C#, C++, those sorts of things. So I think there's maybe two sides to that coin as well.
To me, I don't know if there's a solution to this or not, right? Because and I think I'm guilty of it maybe in a reverse context, right? That I sort of see ideas or concepts from other domains and I'm like, yeah, that's really cool. How hard can that be, right? And then try to sort of do my own thing with that idea. I guess maybe to me personally, the best path forward is just to just sort of be relentlessly engaging with other people, right? And personally interdisciplinary, so that I'm always reaching out to people to include them and build these teams of other people, you know? And certainly it's easy for me to fall into the trap that oh yeah, I know how to code, you know, I've got this, you know, stuff. And then my son has a degree in computer science and mocks me mercilessly for what my programming skills actually are, right? Because turns out an actual degree in computer science is a whole lot more than just knowing how to code, right? So yeah, I don't know. It's a really interesting question, right? How do you get other people to respect the knowledge domain, right, of this profession? I guess maybe it starts with respecting the knowledge domains of other professions, and then reaching out to try to build relationships and build teams with people. But yeah, great question.
Yeah, good question. Is there another question?
Are we concerned that we all use Esri and there's no other products available? Just piggybacking off of Frank's
I don't use
story.
Esri products.
Which ones do you use?
I use mostly open source products, so QGIS, R, GRASS, believe it or not, this still exists, right? Yeah, I mean, if I have to, I use Esri products, but I've moved into the post-Esri phase of my career, so yeah.
Yeah, when I worked for the state and I was in charge of I worked for the Department of Land, setting up all the GIS computers, and I made sure that QGIS and GRASS were on there. Because if you knew Python, you can use the tools from all the softwares, not just the Esri software, which is the dominant one in all of government and lots of other places. We have a...
Okay. I was just going to say, I mean, I think the whole open source idea is really cool. And I've installed open source software and I've used open source libraries in Python and things like that. But I mean, the reality of at least the client, so I would typically work with 50 clients a year over whatever it's been, 10, 15 years. 98% of those clients all used Esri. I mean, it's the reality we live in. I don't know if it's a good or a bad thing, but it's the reality that I've seen in our industry. So, but you know, do I sometimes have a copy of QGIS installed on my laptop? Heck yeah, I do. Because I want to know that tool in case it can do things better, and sometimes there's opportunities to do things better with it.
Yeah, we use Esri a lot here at ISU. We do teach with it because that is almost always, as Frank alluded to, it's almost always what the employers are looking for. But we do use other software. My approach, I guess, is to use the best tool to arrive at a solution. We have another piece of software that I've used for years, decades, called Idrisi Tearset. By the way, Idrisi Tearset is going to become free for absolutely anyone. Early in December, it is stepping away from Clark Labs, kind of retiring it, and a new company is taking it on, but making it absolutely free. So that's cool. Very powerful remote sensing software. We also use LAS tools, command line type of things. In fact, we've pushed LAS tools to some supercomputers here, and we can process LiDAR data literally in seconds. The same job running it here on the workstation, 20 to 30 minutes. So yeah, that's a great tool, automating batch processing and doing it fast. So use the right tool in your toolbox, I think.
Yeah, I agree. Thank you to our panelists, and thank you for being here today. If you have more questions, I think now is a short break, so you're welcome to come up and ask any one of us if you have another question. So I think that concludes this panel discussion for now.
Thank you.
Okay, there it goes. Hi, everyone. Thank you. That was a great first start with our panel. In our next section today, we're doing 5 short talks from different people in our community sharing their work with GIS. And first, we have Andrew Weymouth.
Sharing screen. Do I need to do it over here? Oh, okay.
We have multiple slideshows being presented at the moment. All right, now you can get that one.
Thank you. All right. All right, hello. My name is Andrew Weymouth, and I work with the University of Idaho Library as the Digital Initiatives Librarian in the Center for Digital Inquiry and Learning, or CDIL department. My work generally consists of creating and maintaining our digital collections, helping to rethink processes, and introducing new digital scholarship tools to the department. The short talk that I'll be giving today is part of a larger workshop I created for the 2024 Information Landscape Series on using geolocation tools to identify archival photographs that lack location metadata. While I'm in no way an expert in GIS, my work in digital scholarship regularly has me jumping into various fields and experimenting with them to see if they would be useful to a broader range of student and faculty researchers. With this in mind, I hope this survey is a helpful insight to an outsider's perspective on the strengths and challenges of current free-to-use aerial time-lapse applications. For this survey, I've tested each platform by attempting to create an aerial time-lapse of Moscow, focusing on the longest chronological coverage, highest resolution, and other helpful features like displaying the data sets used or photo dates for viewer reference. Here are a few freely available resources and their different strengths and weaknesses, beginning with the platforms with non-functioning elements or difficult to navigate interfaces. So Google Earth Pro, we have on the top there, and this is a desktop version of Google Earth where some older online references will point you to create aerial time-lapse videos. But this appears to be an outdated model that Google seems to have abandoned for more contemporary platforms. Specifically, the Movie Maker tool that would carry out this action no longer appears to be functional. And then below it, the USGS Earth Explorer database contains material that predates many of the other resources, sometimes as far back as 1950, whereas other platforms can only reach as far back as 1980. Because only still images can be exported, the time-lapse function needs to be done manually in other applications like Adobe Premiere or After Effects. Additionally, as an outsider to GIS, I found the interface unintuitive, as well as some of the semantics, including footprints for boundaries and coverage areas, scenes for individual images, and cart for the download list, even though most of them are free to use for nonprofit purposes. Google Earth advantages are very simple to use. It's got a good date range, reaching all the way back to 1984 in this example task. Weaknesses are very poor resolution and no video export functionality. So you just have to do a screen capture, but that's one extra step. ArcGIS World Imagery Wayback strengths are better resolution than the previous and even more intuitive controls. Weaknesses, historical reach isn't very far. It's only about 10 years to 15 years. And then finally, Google Earth Engine. Because this platform runs on whatever JavaScript code you create, the platform is kind of a sandbox of possibilities where you can create still, moving, or interactive maps, utilizes over 1,000 public data sets, good documentation, example code, and an active community, and easily exports into Drive folders as a Google product. Weaknesses requires a knowledge of coding, and even still can be very difficult and time-consuming to iterate code depending on project needs. Also, possibly because of the breadth of the data sets that it's pulling from, I frequently encountered errors occurring from combining data sets with differing digital color values, differing metadata, and incomplete images. And so just wanted to go into a little bit about one experiment that I did with Google Earth Engine here. So like USGS Earth Explorer, you'll need to sign a waiver confirming that you'll use the resource for nonprofit purposes, but you should gain pretty near immediate access afterwards. The interface resembles a text editor. The left pane displays the scripts that you've written along with documentation and examples of code you can plug in to test the platform. The center pane is where you write and run your code, and the right pane features a console that functions like a terminal, displaying error messages and printing data after running the script. The task pane lists the scripts you've run along with their status. And so all these snippets of code are totally available on the site that I created for this presentation that we'll wind up in. So apologies if the text is a little small with these code snippets. But just to walk through what's happening here, to begin, we define our geographic parameter around Moscow area code. And then next, we'll specify the data sets to use for creating the visualization. Here we're focusing solely on the National Agriculture Imagery Program dataset, which goes back to 1980. And we're doing this due to the many errors I mentioned previously, attempting to chain together datasets to increase the time frame. And then moving ahead to 2, I encountered another complication that not all satellite photographs capture all parts of the area. They don't offer complete coverage, leaving distracting gaps in some of the earlier iterations of the code. And to address this, I adjusted to request only the largest image for each year, ensuring optimal coverage and a better yield of images. A little farther down in the script, we're assembling these images chronologically from earliest to most recent and compiling them into video form to export in RGB color formatting. And then to 3, ideally, I wanted to create code that would automatically overlay date information onto each photograph, providing viewers with better frame of reference. However, the best I could achieve was having the metadata printed in the console that we saw over here. We can see that on the right side over there. There's those dates printed, and then you can just copy those and then plug them into Adobe Premiere, Adobe After Effects, whatever you're working on. And then finally, one of the convenient things about working with Google Earth that I mentioned is you can export videos, images, and interactive maps that you create directly into your Google Drive account. And these exported video files can be converted into GIFs and loaded onto project sites like we'll see on the following page. And so we can see Google Earth time-lapse. It's got lower fidelity, lower resolution, but handily has that time frame. That's an easy reference on the top there. We can see higher resolution on the ArcGIS World Imagery Wayback, and we've got Google Earth Engine, but this required a little bit of formatting because, again, the coding is very tricky to get it to format just so. So in conclusion, I hope this has been an insightful comparison of these platforms and their various strengths and weaknesses. For those needing a tool with around 15 years of coverage, I highly recommend the intuitive ArcGIS World Imagery Wayback platform. That said, very interested in creating more work with Google Earth Engine and the seemingly limitless ability that you have to produce still moving and interactive maps. I also feel like I may have missed some central concepts of the coding to weed out some of those false positives, incomplete images, and data sets with conflicting color configurations that complicated my first interactions with the platform. Thank you.
Next speaker is Ed DeYoung.
Hello again. This one is, I'm going to be talking about the best way to learn GIS. I've been in a GIS and worked in GIS for a long time. I've been a GIS educator for a long time. I've hired lots of GIS people, so I've kind of seen both sides of what you need in that. First of all, I've been an adjunct instructor for the University of Idaho, so I have taught at the Coeur d'Alene campus all the GIS certificate courses. When I was teaching that, we had just about as many students in the certificate program in Coeur d'Alene as we had here on campus in their certificate program. So we were running both of them at the same time. I also taught at Boise State, I was a GIS lecturer teaching GIS full-time there for 4 years. I had lots of students who were in environmental studies, their environmental studies program, and needed to take 1 semester of GIS. So I taught lots of students 1 semester of GIS, and actually about 60 students every semester took their 1 semester in GIS. And I felt kind of bad for them because it's a really big hurdle to learn 1 semester of GIS and then stop, and then not actually become more functional in GIS. So I'm going to look at the university certificate programs. I'm going to do that pretty quickly. Most of you are probably very familiar with that one. I'm going to talk about the options you have for in-person training, for online training, and then end with what is the ideal way to learn GIS. The certificate programs are a good place to start. If you have good instructors, you can learn GIS through a certificate program. It does cost however many semesters, that amount of time to learn GIS. And if you're not doing outside projects, if you're not doing projects as part of your GIS certificate program or your GIS courses, then you only have hands-on is just through the lab exercises. So you can actually get a certificate and have only very limited amount of hands-on use of GIS. And so we'll talk about that a little bit more. Some things that are changing in certificate programs is that Foothills College, it's a college in the San Francisco area. They have a GIS certificate program, and now they have a GIS certificate. So you can get a GIS certificate program level 1, you can get a GIS certificate program level 2, and you can get a GIS certificate program level 3. And the level 3 is as if you just get a degree in GIS. And so they are the first one only one I'm aware of that has different levels of certificates, depending on how many courses you've taken, how many hours you've put in. And then another trend is instead of taking lots of classes, your classes look like projects. So you do lots of real world projects, and you learn GIS that way. And that is another college is doing that kind of education, and that has a lot of advantages as well. In-person training. If you take a Esri course, which there's lots of Esri courses, if you take an in-person course, they're very professional, very helpful. They're very narrow, so they'll teach you just about one thing. And also, like the certificate programs, like if you do a lab, they all have clean data and things work really well if you have the right version of software. If you take something from Esri, you'll always get the most current version. So if you are working and you are like 3 versions old and you want to learn more about it and you take an Esri course, you're going to be learning the new version, not the version you currently have. So that's something to be aware of. Besides Esri, there are lots of, in this region, there are several other trainers. Most of the time you go to a conference, you go to the Idaho GIS conference or go to some conference, and then you'll have options for training as part of that conference. They're very helpful. You pay for them separately, so they are another fee. But also they tend to be, you learn one thing at that training. So you learn how to improve your Python programming, or you learn something very specific in that kind of a training. And you have to go to a conference to where they have the training. You have to go to a larger city where they have the training. You have to go to a larger city where Esri provides the training if you want to do an in-person training. There's lots of things available online. Most of the trainers who train in person also train online. You can take an Esri course online. The Esri courses online are the same cost as if you do it in person, so there's not a big advantage for doing it online for Esri because you're paying the same price. Most other trainers give you a discount if you do something online, so you're not physically having to go somewhere, so they provide it cheaper. Hurdle, the Esri, when they do the training, they always train with the most current software. When you find training online, lots of times you can find very old versions of software being trained. Say you want to learn GRASS GIS, and you find these courses of GRASS GIS online, and you can take them for free, and then you find out that they were created 8 years ago or 5 years ago, and it was the version that it was at that point in time, not the current version that you might currently have. So you have that kind of a lag for some of the online training. Ideal, if you could design the ideal GIS training, you would learn kind of what you need to learn when starting with where you're at, not just single focused on some other thing or just the courses that you're taking in a certificate program. You learn more by using rather than it'd be a combination of understanding what you're doing and knowing how to do it. You'd have help more often. You'd have a connection with the person who's doing the training, and you'd have it at a reasonable cost. That is what I am trying to provide and what I can provide for your organization or for you. I have lots of different ways of doing the training. You can do it in a mentorship program, so you can sort of do it over time. Say a year-long period, you can improve your GIS skills while you're working. You can do it to learn the skills that you need for a new project that you're working on. Or you can come and do it in short events over the year to do it from starting so that you become competent over the year period, but do it in like 4 training sessions for a year. Or you can do it all at once and come and do it a 3-week training and go from beginning to someone who is a GIS technician capable in that amount of time. Or I can do customized training for you. Are there any questions you might have? All right, well, thank you for your attention.
Is Samiha here? Uh-oh. Well, I think that then we'll probably just go on to our next speaker, and if Samiha comes later, we can get her running. So Ruby, get you going. So we have Ruby Strauschen. You can just use the arrows to.
This one, okay. Hi, I'm Ruby Stroshine. I am the principal of Land Value Solutions, which is a software company for doing ag and timber real estate appraisals. And I'm just going to show you some applications that that I apply. So I'm an end user of this. I'm not a programmer. I hire programmers. I try and use mappers. Catherine Hedwich, who maybe some of you know, I hired her to help me with my mapping end of this, and then I have programmers who are in Bosnia, in Sarajevo, and so I get her to collaborate on this. So my history in GIS mapping goes back to when I moved up here in 1997, I started Gem Valley Appraisal Service down in southeast Idaho in the mid-'80s. I started that in Caribou County and then decided I needed to come back to school to get my MAI designation. I had to have an undergraduate. So I started at University of Idaho in '97, and the GIS class I took then, I cannot remember who the professor was, but it was, I decided mapping would be a cool thing to have if I'm an appraiser. I took that class and it literally changed my life. At the time, I was also an adjunct professor in the College of Ag, and so I was teaching farm appraisal and natural resource. And once I took that class, I told all of my students, that's the most important thing you could ever do, is go take that class. And I don't care what you're going to be eventually. It's just that I can tell you 20 years from now, everybody should take GIS mapping and understand it. And so while I don't do what a lot of you do in programming it, I am the end user in this. So that's what I'm going to show you today. Going back, back in about 2000, I was hired to do a project for ITD. Top of Lewiston Hill, I had to do all the appraisals, top of Lewiston Hill to Genesee. There were about 35 different property owners. And so after I took the GIS class, I thought, how can I apply what I learned in there? And so I started thinking about it, and I had access because I was an adjunct professor to Esri. So I found, and probably some of you guys know this fellow, I just can't remember his name. He was going to school at the time, I think, in environmental science, and he was a pilot. So I had him do the aerial photography and georeference my highway right-of-way plans on top of that aerial photography that he did, so that I could apply that and show the property owners, and also in my appraisal, so getting the transparency on it, so I could say this is where the project is going to be. And even though all of the survey markers were down there, until you can really see what that project is going to look like, I was able to show them and myself understanding where the field approaches, are there damages other than just the real estate that they're taking. So I was able to project that in my appraisals. And that was the first time that I used it, which started me thinking about, gee, if I could develop a cloud-based software where I could integrate the cloud-based software with GIS mapping, that would be an awesome tool because it makes that black box transparent. And so if I have to go to court, you know, and I have data points that I need to show in court, I can do that with using a GIS function in my mapping. So when I do an appraisal, the first thing that I do is I want to find out the land ownership, right? And so I can do that by going to my GIS map and connect to the parcel boundaries. And I can click on those, and that will establish the boundary of the property I'm using. And it will also tie into several other things like the ownership, the assessment. All of that information that I can collect from the land ownership. I need to know the land quality. So the software that I've developed, that my developers developed, that I told them what I wanted and needed, because I know we're in JavaScript. That's about all I can tell you. and so I can tell you what I use this for. But in land quality, I need my soil identification. I need to know what the precipitation is. Because when I'm doing farmland here on the Palouse in the central part, I know that 22-inch annual rainfall will produce annual cropping. And then it also gives me the productivity ratings of the soils, right? And so if I'm using a comparable sale, or if I have land maybe over in the dusty Washington area, all of a sudden my precipitation has fallen down to maybe 16 or 17 inches, where you only crop 2 out of 3 years, right? Or going further west, you're down into cropping every other year. So I wouldn't use comparable sales out in that area for, say, a Genesee farm that has a 22-inch or 20-inch rainfall where they do annual cropping. There would be a substantial difference in the value of land, right? And also my frost-free growing days as well. So my resource availability will be locations of both natural resource like streams and rivers, things like that, or transportation systems and like power grids, those kinds of things. And then on laws and code, those regulations, that would be information like in zoning codes, land use codes. So that would be an important one, different districts. And water rights. The last one is risk assessment. There was some talk this morning about risk assessment. And so that would be my FEMA flood maps. That's the most prevalent in this area. There's also earthquake zones. I have some customers that use my software who are in earthquake zones, and they need to have that for lenders. Want to know that wildfire risk if you're doing, or infestation risk if I'm doing timberland, and that sort of information. So here's the old way. So I talked a little bit about the pilot who had to do the flyover and putting that all together, and now I don't have to do that anymore. I can upload my maps, right, and I can georeference those. We used to have a ton of these soil books that I used to have to look up on the soil map. They had a fold-out map, and I'd find my property, and then I would go to that section, and I would pull that information out. And now, once I click on my boundary, and I say Save to Record, I can pull up my soils data, and all of that just populates right into my report, which makes it very nice. I used to have to go down to the assessor's office just to find out where my property boundaries are. So then I'd take a photocopy or copy that map and bring it back to my office. Now I'm tied into Regrid, which is a company out of Detroit, and there are a lot of different companies who provide this information. They're great because I can pay as I grow. So right now, my minimum amount that I can get for 30,000 clicks is about $3,000. And then when I go over that, then it's 10 cents a click for what I use. I also had this whole bevy of these flood maps that I would have to pull out and take a photocopy of that and put that in my map. And again, I can just go into Esri, into FEMA, I'm sorry. I actually, today, now we've talked a lot about Esri, and in my first iteration, I used Esri, and I've switched over to Mapbox. And then most of my other sources that I bring in are open sources. So I have about 11 base maps that I use and about 43 overlays that I use. And I'll show you here in just a minute how I use some of those overlays so you can get an idea of how I use this in mapping. So some of my challenges that I have is the data is housed by different sources. One of the problems that I have, and I'm not sure, maybe some of you can tell me, but I know in Montana, my son works for Department of Natural Resources over there in water adjudication and appropriation. They have one big mapping center that they do everything. So all of, when there are parcel splits, like you guys know, we've had this influx of people coming into Idaho. And so all of the counties have to do these land divisions in their parcels. I was down in Nez Perce County the other day, and I think we've got somebody from Nez Perce County here today, but I was in there visiting with them. And she said when she does her parcel splits, you know, if they take a 40-acre parcel and split off 4 10-acre parcels and subdivide that out, and then they have to redo their maps to reflect that. They don't get reflected, that doesn't come through until the following year. So while I may get the information on that, I don't see it downloading into my system for a longer time. I know in Montana, everything is done in one central mapping, everything. So rather than each one of the counties, so they can get that information out to their users faster than a lot of times we do here in Idaho. Sometimes the data is in different formats. That can be a challenge. I talked about getting that information, my parcel data. That can be very costly. And then we talked a little bit about data privacy. One thing I ran into was in Farm Service Agency. I used to could get all that mapping information of what the crop acres are with Farm Service Agency. I cannot get that anymore. It's proprietary. I can get the map from them if I get the landowner or the tenant's permission to get it. That's the only way, but I cannot get it through a user interface. So that ends up being a bit of a challenge for me. So here's just a little bit of the way my system works. If I select this, then I'm going to save it to the system. It gives me all the information that's over on the left-hand side. And then, another source, then I put it in. I can pull up my soil data. I'm going to save that to the record. And then all of that information is going to populate in. So that gives you a little example there. Another one is my FEMA layer. So this would be the flood map. And then I also can go into PLSS, which is the Public Land Survey System for Township Range section. And that will give me, when I'm zooming out here, it will give me my different sections, township and range. And then if I zoom back in on this, and I can go up and turn on my parcel layers. I can see who the owners are of the land, so I can see what's around it. I can also put in layers that tell me if it's public land or privately owned land. So when I save that to record, then this is the information that I've highlighted that will populate into my record that will eventually go into my report, and that would tell me the elevation, the soils, the frost-free days, the precipitation, the topography, and down at the bottom, that is that is a productivity rating on the soil. It also will give me, if I'm in timberland areas, it will also, Catherine did this, and I love her for it, because I was having to go back to the USDA maps to get the productivity on the site index and also productivity rating on timber. So that has been very useful for me. So examples of how I might use this would be on a scenario, if a landowner wants me to appraise it and is it a wind farm, you know, and I go out and he thinks, hey, the wind blows out here a lot. I could have a wind farm out here. So I want to appraise that value. Is that in fact the highest and best use? So I can put a layer over that and I can say, yes, here's the power grid that's close by, and I can put my wind farm layer over top and say, well, here are a bunch of wind farms. This was up in Whitman County. And so, yeah, is that, you know, there are probably some other variables that I've got to check on before I say definitively, yes, this could be a wind farm, supply and demand and those kind of things. But yeah, you know, we could look at this as a wind farm based on the information that I've been able to gather from that. Another one might be, this is a farm over in Walla Walla, and if they wanted to put, let's say, change of use to a vineyard, but the vineyard needs to be in an AVA. Anybody know what AVA is? Okay, so, and that is the American Viniculture Association. And those give boundary lines for climatic, geographic, geologic. So it identifies that area to say, this is in the Walla Walla AVA, the light colored one. The other one is actually in Columbia Valley AVA. So if you have to put your vineyard inside your Walla Walla AVA, then this would tell me if in fact they're in that AVA. The same thing when I go just appraise a vineyard over in Central Washington, then I can put that layer on and it tells me what AVA that they're actually in. So that's what I use it for, and that's my practical application. And I'm just like a #1 lover and user of GIS mapping. As long as I have really good, I have to say, Ava Strand, way back when I was teaching my class, once I took GIS mapping, I said, you have to come over and tell my students how wonderful this application is. So, so that's, thank you, appreciate it.
Okay, we're gonna have Sashwat come up. Oops. It's not on my screen. There we go. Okay. Yeah, you can just use the arrow buttons. So next we have Shashwat Nirala.
All right. Hi, everyone. How is everyone doing? So good morning, everyone. My name is Shashwat Nirala, and today I'm excited to share my computer science journey with GIS. And then, so let's get started. So a little bit about myself. I'm originally from Nepal. And then currently I'm a senior majoring in computer science, along with 2 of my undergraduate certificate, that is in AI machine learning and then GIS. So those are the things that I'm up to in U of I. And then my journey to GIS has been a roller coaster ride. So it has been. So I started as an intern in Intermountain Forestry Cooperative in Moscow. It was summer of 2023. And then from there, I came to know about GIS and what GIS is and like how do we use GIS. And I think from that internship, I got to know a lot about GIS and then what Esri is. And then at the end, I did intern in Esri, so my ride has been a roller coaster. And then after doing that internship, where I did some visualization, where I did geographical analysis using Google Earth Engine, and then used JavaScript and did a lot of analyzing. And then from there, I got to know there is a GIS certification course in U of I, and then I got interested into it. And then from there, I started taking GIS classes. I started with remote sensing, and then I got to take some basic level of GIS course where I got to know about the foundation of GIS. And then after that, I started doing my self project. So I started building up some application where I used my programming skill with GIS and then integrated it and created some map, which I will show you later in my slides. And then after that, I was searching for internship, like where I could work in next summer. And then I wanted to use my CS skill with GIS. So Esri was the best sport to get into. So I did apply for Esri, and then I got accepted into Esri. And then last summer, I was interning in Esri in California. And then that was like kind of a life-changing moment for me, because in GIS field, Esri is like Google. So working in Google for us has definitely changed my life. And then after completing my intern in Esri as a software product intern, I'm currently interning in WSP as a GIS developer. So I'm still like being a CS major, I'm interning as a GIS developer. So that is what is happening in my life. And then I would like to talk about like some fun stuff that I did in Esri. So one of the things that I did in Esri was, so I don't know how many of you are familiar with Google Colab. So Google Colab is basically a hosted Jupyter notebook, but it is provided by Google and it's free of use. And when I went to Esri, so there wasn't that many people who were using Google Colab. And I came to know Google Colab by like some of my creative project in like machine learning and deep learning. And then I used to always wonder like how I can integrate Google Colab with ArcGIS and then different product that Esri has. And then finally, I had that opportunity to work on Google Colab and then integrate all those Esri's Python API into Google Colab. And I was the first to do it in Esri. So they made sure my resources were fully documented. So they made me publish a tutorial in YouTube. So you can scan this QR code and then see the tutorial in Esri's YouTube channel. And I am the one that is narrating it. And then after that, so this is basically a code that I wrote using ArcGIS API for Python to do spatial analysis. And basically this is all in Google Colab. So this is a basic example of how I counted the graffiti incident column in Census Block. I think it is in San Francisco. And then, so to only do this, if you want to use Esri technology like ArcGIS Pro, you need to pay for it, and then it requires a lot of money. But if you want to do it outside of ArcGIS Pro, you can always use Esri's API, and then you can simply do it in Google Colab. So that makes a lot of work easier. And this is another thing that you can do in Google Colab. There are a lot of things that you can use Esri's API to do in Google Colab. So that is like kind of a thing that fascinates me the most, and still I am using Google Colab to do a lot of Esri's thing. And then there are also 2 of my blog articles published in Esri's blog page, where I did talk about like how I got started in Google Colab using Esri's Python API. And the next one is how, so I was also planning to complete a Python associate certification from Esri's Academy. And then I wrote like, what was my experience, how did it go? And then I couldn't finish it because of my short time in internship, but I have like listed every process, what I did and what people needs to do if they wanna proceed forward and get the certification for Python. And then following up on this, I would like to talk about a project that I did. So as I was in summer, during my time in Esri, I learned a lot of new tools, and then I wanted to create something new, something meaningful to everyday's life. So while living in California, I did travel a lot. And then for me, it was very hard for me to, like navigate where I went. And then I always wanted to track where I went and where I had so much fun. So I came up with Geolocate. It is a web-based application which I designed to create some time lapse and then visualize like the pictures that I take. So I should have a link for this, but I do have a video which will show like how this works. And if you want to try this, you can scan this QR code, and then this website will be live there. So you can scan this and then work on it. So yeah, let's see how this works. So basically what you want to do is you want to choose a file, you choose a picture. So there are a few pictures that I wanted to have, and that's all. And then if I upload them, they will take you to the points where you took the picture. So I upload 4 pictures, but I think only 3 of them got there because one of the picture didn't had EXIF, which is attached to those pictures. So what I did in this program was, so there is a thing called EXIF in all the pictures and all the images that we took, and then I extracted all these metadata information from that file and then attached it into this web page, and then I can locate these. I can see like where I went exactly and in that point, and then this is like kind of a thing that is really impressive. And then even like, let's say if you wanna see like where you went 10 years back, you can always like take that picture and upload this in here, and then you can see, oh, I went to this place, I went with this friend, and then I did those kind of stuff. So that is it. And then also I did add an option to download a CSV file because it has both latitude and longitude, and then you can always plot this in. So the reason why I did this was, so in Esri's technology, so if you are using Esri's ArcGIS Online, so you can upload your CSV file there, and then you can plot that in map. So if you plot this data in Esri's map, you can do a lot of analyzing inside there. So the only motive that I had when planning this was I wanted to plot this into Esri's ArcGIS Online, and from there I wanted to do like some machine learning and deep learning model check where I could analyze like where I went and then where are other people gonna go. So that's one of the reasons I use this. But yeah, this is something that excites me, and then I always love working with maps, so that's why I created this. And then this is it. And then, yeah, so I think that was quick, and that was all from me. And if you have any question, feel free to ask me. And if you want to follow me, yeah, I have my LinkedIn link there, and then I do upload a lot of things about GIS. So yeah, feel free to follow me and then send me an invite.
Thank you. This is your presentation, yes? Okay, great. Full screen. And then you can just use these arrows here. So our last speaker for this morning session is Samiha Ali.
Morning, everyone. Before I start, I would ask you one question. Do you know how much farmers have to pay for crop insurance premium every year at the Pacific Northwest? Any idea? Last year they had to pay around 159.5 million. That includes 655 per crop per county. I'm Samiha Ali. I'm doing my master's with Dr. Erin Brooks in the Department of Soil and Water Systems. So this research that I'm doing currently is actually assessing the benefits of conservation tillage aside conventional tillage practice with different crop rotation, since we have a lot of heat stress coming every year, peaking at July and August, and also drought, very frequently occurring drought that occurs every 2 and 3 years. So this research that I'm currently doing with Dr. Brooks basically focuses on how, first of all, we can reduce the amount of crop insurance premium that farmers pay every single year. And also at the same time, controlling the crop loss that is damaged due to the heat stress and the drought. And also we're trying to promote the varieties of different crops. Those are drought friendly or resistant to drought. That could be sustainable with the different crop rotations that we have at the PNW. And all this data that I have used for my current research until now that I have used with the remotely sensed data. So for this research, I have used a couple of tools. Those are like PolluSet, the CropScape land layer, the tool that helped me get all the information about the crop rotations that are performed within the PNW. My study region is basically the Whitman County. I look over the different regions in Whitman County that are highly affected by drought and heat stress, and also the areas that reach less irrigations. So I have the currently, until now, up to the point that the project has proceeded, I've extracted the data from 20 different fields that include conservation and conventional tillage practice. So here, as you can see, this is one of the 2021 is one of the drought years that we have recently. And due to the drought year, we had usually the crop residue cover from September to November every year is pretty high, around 80 to 90%. But because of the drought year, the highest residue cover at that time of 2021, that has drastically lowered until 39%. So you might have probably know if you know about conservation tillage practice. So conservation tillage practice mostly depends on the residues from the previous season that's been already harvested. So it helps with the soil remediation, and also when we are doing the conservation tillage practice for all the tillage equipments, the soil is highly churned, and therefore the microbial system underneath is highly affected. And in terms of conservation tillage practice, the microbiome in the soil is very much well preserved. And from those fields, we have on the western part of the Whitman County, you can see most of the drought-resistant varieties, because in those areas, the fields that we have on the western part, those are more prone to the damage of drought, since there is less irrigation system, and also the snow melt or the precipitation that we receive in the whole Whitman County is less on the western part than the eastern part. So we have more variety of crops in the eastern part, also with the cover crops. And this map, this particular one, I have created from the CropScape tool from extracting the cropland layer. It includes all the crop rotations that follows within the last 9 years of time that's been cultivated. And also it includes the NDVI. I extracted it from the climate engine and the OpenET. It was very helpful for me. So the peak NDVI basically shows us how much of intensity that we had in terms of crops in the peak season, and also in the terms in the years that were highly drought prone. The data I have over here, so from the observation from the past couple of years of our study, as we can see, the no-till farms worked best with conservation tillage. For the no-till farms, they had the highest crop residue. They helped the drought years mostly, or the heat stress time to grow better growth of crops in terms of the tilled farms. And also the NDVI was very high on the peak seasons. You can see some drastic drop in the years of 2018 and 2021 because those were the drought years. So the study is still going on. These were all observations until now we had. So from the observations, I can definitely say conservation tillage practice helps a lot aside of the conventional practice to help sustain the crops and reduce the damage that the farmers have each year for heat stress and drought. Thank you so much.
I was just wondering how you were able to determine.
Sorry. Make sure our online folks can hear.
Okay. I was just wondering how you were able to determine crop residue cover in the loose.
We need an extra microphone. I should get that one.
You get your exercise in today, Bruce.
Okay, thank you for your question. So the PolluSat engine, it is very helpful. It basically, when you are, if you get in the PolluSat tool, the website that provides you the areas with the polygons, you just have to mark down the polygons and create the areas of your designated study. And that gives you the residue cover, the NDVI, and the NDTI all in one together. So what I did for the graphs that I had, I can just show you over here. So these are basically the mean residue covers I have prepared for all the fields, the designated fields that I took that had conservation and conventional both sort of tillage. Okay, thank you. I'm just keeping it like that.
Anybody else? All right. Well, thank you. So that's going to be it for our morning session of short talks. We have a little bit of a break and coming back at 11:30.
So from all the way from Burley, Idaho, which I'm more familiar with than you might think, we have Wilma Robertson, the Geographic Information Officer / Chief Data Officer, and Megan Wheatley, a GIS Analyst 3 from the Burley office of Infotech, is that correct? Office of Information Technology for the state of Idaho. And then we have Bradley Bean, hopefully joining us. Is he on yet, Matthew? Okay, well, maybe Bradley will be joining us later, but they're going to talk about journey building the Idaho map. So if we have questions, we can save those for the end and I can come around with a mic. But Megan and Wilma, thank you so much for being here and for presenting on this.
All right, yes, are we? Okay, and just checking, can everybody hear us? Oh, not yet. Can everybody hear us?
You sound good in the room, I think.
Okay.
Oh my gosh. What is happening? Sorry, technical difficulties.
Oh, host disabled participant screen sharing. Can we share our screen?
One moment, as always with Zoom, we have these fun empty times in our life. Okay, you should be able to share now.
All right, let's try that.
Apologies.
Okay, share.
Okay, it's starting. Yes, we have you. Thank you so much.
Okay, good. We have audio and visual, so I think we're good to go. So it's been quite a journey, and I think a whole bunch of folks in Boise as well as in Moscow probably been on this journey even longer than I have. I mean, just thinking about Frank, he probably was working on this like decades ago, and then Bruce has been working on this, and it's been a long time. So recently I had a chance to talk to Nathan Bentley, who was the GIO like 4 GIOs ago, I think around 2006, 2007. And he's like, yeah, no, we were working on this. So at least 20 years. And he was saying probably closer to 30 years. So let's take a look a little bit at the history of how this came to be and really what it is and how close we are. Okay. Yeah.
Oh, there we go.
Okay. So I figured I should just put an old T4 fort in the back because I think that's about the right era. So this is kind of cool. 1978. I mean, we're talking a long time ago. The Idaho Image Facility at IDWR was formed. Some of it in like executive
Sorry for
order.
interrupting. Are you moving the slides? Because we're not seeing the next one.
Oh, yes, we are moving the slides.
I think it's sharing not the presenter's version. I think it's just sharing maybe the PowerPoint version or.
Oh, let's see. Apologies.
Okay, we still see the little thumbnails of the slides on the side. Is that what you're seeing too?
Yeah.
Okay.
I'm gonna get into presenter mode. It doesn't want to work.
Okay, well, we might just have to show you in slides. Slides show like the.
Oh, that's fine.
Design, right? So, okay, so let's just go to the second one, the second slide. All right, so here's
Perfect, thank you.
The Model T4. You guys are not seeing it here now. Just picture a Model T4 and I'll just try and verbally paint a picture here.
Can you guys see that?
Yeah.
Or in Moscow?
Yeah, we could see it before too, like when you switch the slides. So now we're seeing like the presenter's version, but it's totally fine. We can see it now at least.
Okay, okay. Very good. Okay, so in the 1980s, there was the first Mapping Advisory Council. 1988 was translated into the Geographic Information Advisory Council. And then the Idaho Geospatial Council, which is really, this is an IGC meeting. We do this twice a year to basically talk to you about what the Idaho Geospatial Council Executive Committee has been up to. Was named such in 2001. So it's kind of cool because there's so many. Can we move this? I'm looking at a lectern instead of the audience here. Okay. Oh, there you guys are. Okay. So there's actually some states that are still struggling to form one of those councils. And so I think Idaho, front runner, I think we are one of the oldest councils. So that's really kind of cool. I put in how long ago it was. So at least 46 years old. So I think the IGC equivalent's probably older than many of you. Looking at you, I hope they're older than you. Okay. And so, yeah, if you can, oh, this is an older slide, but so here, just let's get all the pictures on here. So really the objective of the Idaho Geospatial Council is to work together. Like we as GIS folks, we're really gregarious. I mean, if we don't share our data, then your map's just going to have your data, and our map's going to have our data, and it's going to look sparse on both ends. Which when people go like, oh, no, we don't want to share our data, then you're like, well, but we're sharing with you, right? Come on, share back. And so that's one of the objectives. And also just a network like we're doing right here. And if there's, issues that need to be addressed, to elevate those. So for example, if you start hearing rumors that the National Agriculture Imagery Program is going to start charging for imagery, and you hear those kind of rumors, which that's a rumor, that's not true, by the way. But things like that, or maybe the FCC wants to release a new frequency that basically uses the same frequency that your equipment runs on. Things like that that could potentially be big problems for us. Those are the things, once you pick them up, we can elevate it to a higher level, and we can basically speak on behalf of the whole GIS community. And then we can send a letter to the legislature or a letter to, the federal government going like, no, please don't do that, because this will, result in X and Y harm. And so then the IGC EC, we meet every other month. And for that, again, we talk about the issues that have been elevated. We have updates on all the different data sets and the progress on different data sets in Idaho. So for example, when the USGS releases the next, version of the National Hydrography data set, or basically how that's going with their new program, those are the kind of things that you can pick up there. And then the objectives of the ITA. So there's a hierarchy right there. So the ITA is an Idaho Technology Authority. It's in statute. It's a state thing. And so they meet like twice a year. And it's mostly just, there's a couple of legislators on there. They're just directors from different agencies, and it's very state focused. But under there are different other committees. So there's like a cyber committee. There's one that just looks at IT technology. And then there's us, the Idaho Geospatial Council. So anything that the Idaho Geospatial Council decides really only applies to state agencies. And I think we only have like 3 or 4 of the 16 positions that are state people. So if you truly hate the state, then come on our committee, pass terrible rules, and then we are stuck with it, right? Or maybe don't do that. But as some of the main goals, we really want to look at how can we connect better? How can we make data sharing better? And so for years, we have been working on something called the Idaho map. So on the national level, this is called the National Spatial Data Infrastructure. And I know, for example, transportation, there's a couple of layers that you guys have to report up to the feds, and then they can put out like nationwide data sets. And this requires standards in different states to be the same as on the national level. Another really good example, I'm not sure if any of you work with the National Hydrography data set. There's a very specific standard. They got state stewards that are then, promoting this data up to the federal level. And that's how we end up with really good data at the federal level. Because it's the locals that know what's going on, right? And then, we have locals everywhere to get up to the best national data set. So there's renewed efforts looking at the National Spatial Data Infrastructure. But here in Idaho, I think it was around 2010, we got a grant to start building out our Idaho Spatial Data Infrastructure. And I keep using that word, spatial data infrastructure. So what does that mean? So let's go to the next slide. So there's many different pieces to it. So underneath our IGC-EC, we have different technical working groups. So let's take, for example, transportation. So we meet and we talk about, now what are those data sets that people really need, those core basic data sets where it would be great to have a really good statewide layer. And so let's say trails. And then we start thinking, okay, people really would like to have the trails, motorized trails, non-motorized trails. Who has that data set? Like, what is the authoritative source? Like, who has either the legislative authority or the mandate to create that data? Or really, where does this data come from? Some examples are parcel data. Counties create parcel data. They have to create parcel data per statute. And so they are the authoritative source. For many folks here working for, cities, you're the ones that assigns addresses to like new developments. So you are the authoritative source for that. If we wanted to talk authoritative source, we could fill a whole hour. That's one of those words where anyway, go with it for now. And so let's talk about parcels because, we can go like, okay, it's fine. Parcels, counties have the best parcel data, authoritative source, that's it. But we also need to set up agreements with the counties to basically share this data up to the state, send it to Megan. And then, she's standardizing it and she is, aggregating it and basically then releasing it as part of our Idaho spatial data infrastructure, which we just, lovingly call TIM, the Idaho map. Then we need to make sure that this data is available, it's shared, there's a process in place. We need to make sure that all the attributes that we find in the parcels, we agree on. So that's where the technical working groups talk about that. There's governance around this data. So how do we make sure that this data stays updated and accurate? Then we need to have those standards, give it some official status by approving it and reviewing it through the Idaho Geospatial Council Executive Committee. Then we need to nominate it. We need to know who the data owner is. We need to know who the steward is. And so on. You keep looking at the clock, so I'm thinking if my time's up.
No.
Okay.
I'm just,
Okay, it just,
no, I'm just looking at. It's hard to see.
okay. Anyway, I think this was my last slide, so I'm gonna happily move it over to yeah. Go, take it away.
So these are our current frameworks for the Idaho spatial data infrastructure. So you can see we have all of these different frameworks, which are relating back to what we call technical working groups, or sometimes if you are on the geotech list, you'll see it as TWG. Also, we call it twigs. And we have a range of groups and a range of different parcel or chairs for these groups. So for example, I am the chair of the parcel technical working group as I'm working on that statewide standardized parcel layer. But we also have, the geodetic control point group, twig, and Keith Weber and Stuart Ward are the co-chairs of that. And so Jackie Reeder in the room here in Burley, she's the chair of the geosciences twig. So we really use these frameworks to help bring people together, no matter what part of the state that they are, because they have stakeholders, they are knowledgeable in that area more so than just, maybe you're specializing in parcels or maybe you're not, right? So bringing people together on what their knowledge is and sharing that with the group so we can continue to move forward with our Idaho spatial data infrastructure. So one of the things I kind of wanted to talk about here is the technology behind our Idaho map, right? This Idaho spatial data infrastructure we keep talking about. So we are working on a draft and we hope to have it out soon for the public to be able to use. And some of that technology that we're leveraging is actually ArcGIS Online. With that, we're hosting all of our feature services. We're grabbing different services from other agencies or educational institutions such as like University of Idaho. We utilize Bruce in the library there to get all the different NAPE imageries and things like that. And our whole framework for this web application is Experience Builder. So we've become really good and well-versed at experience builder as we keep looking at the different functionalities within that. And then also we're leveraging Survey 123 Connect to build back feedback surveys, right? Because this doesn't work without, the public or other agencies and stakeholders. We want feedback from you. We want to hear what you guys actually use in your work. And, even for students that may be in the room, like what data are you looking for different projects? We've heard this a lot from other states. Their data is out there and it's really hard to find Idaho data, right? You have to look in a lot of different hidey holes to find it. And then ArcGIS Hub for our open data site, where you can easily find the different technical working groups that it's a part of, which Brad will talk about in a little bit. But easily one place where you can easily find all the data associated with that.
So can I jump in here? I would like to define the word our. I mean, that is just, it's not our, it's everybody here, our. I mean, you're at an IGC event. IGC can be attended by every geospatial professional in the state. It's open to everybody. And those technical working groups, they're open to everybody. So even though we're like hands on the keyboard trying to, actually bring it to fruition, it's not ours. It's like all of ours. So keep that in mind, as it's not just another effort in one state agency that's just trying to do their own thing. It's not. We're trying to make this as broad and encompassing as possible. So we do need all of your help and we do need your expertise. So yeah, keep your ears open for opportunities to participate. And what is it? Many hands make light work. So yeah.
So just touching a little bit on this, to Wilma's point, right? Where's the data coming from? It's not in every state agency. We have to work with federal agencies. We have to work with you and everyone around Idaho. What do you actually use, right? And part of these technical working groups is to find those different data sets that people really want to see, and identify who the authority is. So this is something we just talked about recently in the geosciences twig, actually yesterday. We have a bunch of different ideas for data sets and we're like, oh, where would we find those? And who can we contact to reach out, maybe have some group presentations so we can get more buy-in from other folks, right?
And we can all learn from those folks that are producing those data sets. I mean, you were looking at like mining deposits and things like that. I mean, who here would just love to spend half an hour talking to the folks that are actually creating this data, work with this data, just to understand what they're doing and what their job is like.
Yeah, and the part of the Idaho map is not only, finding for GIS people, it's for everyone, whether you're a GIS person or not. You just want to see data, right? If you're new to Idaho or you want to tour Idaho, right? So data sets like hot springs and, where cool businesses like, hey, I've never been to Boise before. I've never been to Sandpoint. Where are the cool businesses, right? So bringing in all these data sets that might be of interest to anyone, and we have a technical working group and a framework for each and all of those data sets. So these technical working groups are just a way to bring all those stakeholders and people who are interested together and finding these different data sets. So some of that process and how the data gets within the Idaho map is, of course, we talk about it in the technical working groups, but then we come up and find what data and we write standards and nominations and the approval process starts, which happens from the Idaho Geospatial Council Executive Committee. And they go through and approve these after the standard has been vetted. Everyone in the technical working group has talked about it, agreed on it, right? We don't want to move on if no one agrees on it, right? Then people don't want to use the data. How is it going to benefit all of us? So those are some of the processes that we go through.
Oh, and I think one of the things that is always hard is when you need data, right? And you're like, okay, I can download it right here, but I need to have it on ArcGIS Online. So you publish it to ArcGIS Online. So now technically we have a copy of authoritative data published by somebody who's not the source, and you're probably not going to update it. So one of the things we want to accomplish here is for everybody to know, where do I go to get the one authoritative source, and also discourage people from republishing the same thing over and over and over again, just to help clean that up and just give people confidence that this is the best available.
Yeah, and the last point on this is pulling from the authoritative source, right? Wilma mentioned we could talk about that all day, and these are some of the things that we do discuss in the technical working groups, especially with some data sets and frameworks. So we really want to only have authoritative sources within the Idaho map, or if we can't find any authoritative sources for Idaho, the best absolutely available. So that's kind of where our thought process and talking with each and every one of you and the folks that come to the technical working groups, it does not work without you. It really doesn't. So next, I think it's Brad. Brad, are you on?
I am. Can you hear me?
Yes.
Awesome. Great. So we are super excited. I'm sure they said it at the beginning. I apologize, a few technical issues running between rooms here. But we're super excited to be launching the Idaho map at the beginning of December for everybody to use. We won't have every data set that we want to on there at that point. It's still going to be a continued work. But I just wanted to run through a few slides and present what the Idaho map currently looks like and what each tab on our experience builder will contain. So when you open the Idaho map, this will be your default view. You're going to have the NAPE imagery for Idaho load. Those of you who have worked with the most recent NAPE imagery will know that there is a section up in northern Idaho that has a nice hole in it for the moment. We are working to fill that with the previous NAPE though, so that will be the default view when this launches. And then you have your layers and legends tab or buttons that you can add the different layers that have been approved by the Idaho Geospatial Council and appear as authoritative or, as Megan said, best available data sets. And then you've got your legend to see what those are looking like in your map. So we've masked off anything that's not Idaho because we don't this is the Idaho map, not the Oregon and Montana map. There are a few things that do extend farther. You can see the hydrography data set is pretty complete on there, even though it's behind a mask. And then some of our hazards layers, like our earthquakes, include things that are near Idaho that might not have fallen directly in Idaho. But obviously the state is the focus in this one. And then our layers tab, this is where we can find a list of the different technical working groups on the left-hand side and the different data sets that they have produced or are in progress of producing. Well, not necessarily producing. Producing is the wrong word. Sourcing is a lot of the case. If possible, we're not looking to recreate, as Wilma said, we don't want 17 different versions of the same data set. We would like to have the one authoritative data set, and often that already exists. Things like geology layers from the USGS, things like climate data, those already exist. We just want to provide the easiest way to get to those. So on these cards that will appear under the different categories, there are links to the metadata behind the layer, the standard and nomination. So the standard is going to tell us what the minimum requirements for that layer are. And then the nomination is the actual nominated data set with a link to the Open Data Hub, which we'll look at in just a second. That Open Data Hub is where you can go in, download that data set, use it in your GIS needs. It's not shown
Don't
on this.
download it. Refer
Yes,
to
sorry.
it. It's at the
Use it.
restaurant.
Wilma is correct. Please don't download it unless you really need to, in which case I suppose you can. Not shown on this slide, we do have some layers that are still under construction, still working to be approved. So those will be grayed out cards, letting you know that they are coming soon. And we also have some layers that we've pinpointed as things that we want to add to the Idaho map that are not shown on here yet because they have not even been a standard has not even been produced as of yet. Our team and the technical working groups are working hard to provide new data as we go along. And the third tab across the top links us to our Open Data Hub. There's also other ways to get there. The links on the layers list obviously are one major way. This is similar to the last where some of our technical working groups do not yet have a data set that is published on the Idaho map. Those symbols are grayed out. You technically can still click the link and it will take you to that page, but there won't be anything in there quite yet. For those, this is where you can search and not download. Sorry, I should have consulted first here, because to cross out download, we're going to say utilize those layers. And we also have included, if you see kind of at the top left of the inset where it says refresh this page, some of the feedback that we received was that in the Idaho map, when you have the open data tab up, there was no way to just refresh that page and get back to the main. So that is a button that you can use to return to this main screen, even if you're into one of the technical working groups. And then,
I'm working on it.
oh, you're good. The next slide is going to be our topic maps. Right now, we only have one. So the idea behind these topic maps are they're going to be compilations of layers, or probably web applications that are going to highlight different series of maps for different purposes. The one that is currently on here is our parcel viewer. This is a map of the parcels in Idaho and those counties that we do have buy-in for, that have allowed us to share their parcels publicly. Can be found here along with the parcel data. But future topics that we have looked at include things like real estate maps. I think we've discussed a potential health map, and then hazards as well are some major future maps to come, future apps that will be available here for specific topics. And then our final tab is our help and about tab. Definitely still under construction, but we have some things like what is the Idaho map, how we navigate it, our frequently asked questions. We are working to create a list of the layers and their REST endpoints, so that it's easy to find where this data is coming from. We've had discussions with people providing feedback that as many methods as possible of getting to that REST endpoint to that data is better, and we agree. There will be a page with a form to contact us about the Idaho map, provide feedback. You can also, I would love it if you want to offer your support and volunteer for our technical working groups. There's many ways to do that, but you can always just send a contact us. We'll point you in the right direction, as well as the legal terms and conditions that also pop up when you open the Idaho map for the first time. So as of now, those are the tabs that we have in the Idaho map, and we're excited for everyone to begin using it in December.
So our soft launch is it's on December 4th. When I do a presentation about this to, it's like a cyber and emergency conference organized by the Office of Emergency Management in Boise. But I would like to do like an official launch in early next year to really start advertising it and having a soft launch, and hopefully have you guys take a look at it, see how usable it is. Just still provide us feedback. There will be a survey embedded. I mean, again, this is a collective effort. So if you have like your pop-up looks bad, here's the arcade code to make it better, you know. So that is typical, that is truly constructive feedback, right? Like seriously, here are the building blocks, make it better. But yeah, your input is greatly appreciated.
So do we have any questions? We might have time for one question before we have to move along, unfortunately. Any questions? I'm actually excited to take this home to my husband and let him know about it, because he works for the state of Idaho too, and I think he'll find it very useful. So thank you for all your hard work. Any questions from the room in Burley?
Oh my God. Nothing here. So just for reference, I am envisioning we can get up to 100 different layers on here. I think there's enough different topics. Currently we're at 17, so there's still a lot of work to be done. A lot of help that we need. Yeah.
No, this is great. Thank you so much. Appreciate you presenting on this topic.
Thank you. Thank you.
All right, thank you, everyone. So that concludes the morning sessions. We're going to break now for lunch for about an hour and 10 minutes. And there's food in the back here for folks in the room. For folks online, enjoy your lunch. We'll see you in a little over an hour. And if folks in the room, if you haven't registered for the raffle, which we'll do about in about 12:45, there's flyers on the desk. It's for, Esri gave us 5 ArcGIS for personal use licenses. So if you're interested in trying to get one there, we'll do a raffle. So enjoy your lunch, visit, talk to people, and we'll come back for the panel discussion and short talks for the afternoon in about an hour. I think we're ready to get started here. I'm gonna stop this. So do I need to, Evan, do I need to start anything up here to bring in Danielle and Fred? Oh, she good. Okay, perfect. Okay. Welcome, Danielle and Fred. You guys hear us okay? Just want to make sure. We'll test your audio. Could you guys each give us a test?
Hey, Bruce. Can hear you well.
Fred's on.
Hello, Bruce. Hello, Bill. Hello, Fred.
Okay, Danielle, great. Excellent. Well, let's get started for our second panel of the day. And for folks who are here for the first one, this is going to be pretty similar to our first panel in terms of structure. But this one, we're going to focus on data quality, access, and collaboration. And we've got 3 folks here who have been in the game for quite a while, so to speak. And I'm going to give them an opportunity to introduce themselves and give us their perspective on what they feel have been really transformative changes for GIS data quality, access, and collaboration over the past 25 years. And following there, each have up to 5 minutes. Following that portion, we'll go into a set of curated questions that I've put together that I've provided them that we'll work through. Might not get through all of them. Followed by that, we'll have a question and answer session. So folks in the room and folks online, if you type your questions in the chat, we have a moderator for that. And hopefully we'll have a good discussion following up on our education, training, and service discussion. So welcome all our panelists. So we're going to start out. I'm going to let each of you introduce yourselves. You get up to 5 minutes to introduce yourselves and then speak about what the most transformative changes to GIS data quality, access, and collaboration have been over the past 25 years. I'll go at random. How about if Danielle, you want to lead us off?
Sure, Bruce, I'd be glad to. Good afternoon, everyone. My name is Danielle Favreau, and I am the Water Resources Information Section Manager at the Idaho Department of Water Resources. And I've been supporting GIS for IDWR since about 2005. And I've been in the GIS business since about the late 90s. I won't be too specific on that. And I've seen GIS, especially at IDWR, transition from ArcView 3.3. In fact, I even have a shrink-wrapped copy of ArcView 3.0 at my office. All the way through ArcMap to ArcGIS Pro today. Seen a lot of changes throughout the years, especially in how we do data, just do GIS also just in general. I've been an active participant in the GIS community as part of the Hydrography Technical Working Group Chair as part of IGCEC, working on framework data. And I have participated in Northern Rockies ERISA. Also too, I just like to do general GIS education, including we're participating at City of Boise's Map Mania and other education activities. I'm going to kind of just list a couple of highlights I consider throughout the years. I'm going to start a little bit further back than 1999. I'm going to go to 1998 when Tom Hanks and Meg Ryan starred in the romantic comedy You've Got Mail, where the lead meets her love interest in a chat room they access using the respective AOL email accounts over 56 kilobyte telephone modems. And about that time, there were less than 50% of US adults online. In May 2000, at the direction of President Bill Clinton, selective availability was removed from GPS in order to make GPS more responsive to civil and commercial users. For those who don't know, selective availability was the intentional degradation of GPS signals. Basically, it added 50-meter horizontal and 100-meter vertical degradation of GPS signals. So basically, raw GPS collections look like Etch-a-Sketches. And if you don't know what an Etch-a-Sketch is, just ask the person who knows about You Got Mail, and they'll tell you what an Etch-a-Sketch is. Google Map was released in 2005 as a way to get from point A to B, and Google Earth was released a few months later. I now finally could describe to my mom what I did for a living. And also internet speeds were up to about 1 megabyte per second. In 2007, the first Apple iPhone was released, signaling the beginning of the average person having mobile data collection device at their disposal. In 2010, NAPE imagery is now collected using digital cameras, signifying a shift from film to digital photography. 2017, Sentinel-2B is launched, providing a 10-meter imagery alternative to Landsat. 2018, FCC approved the use of Galileo in the US, launching the development of GNS chipsets featuring more than just one GPS. In 2020, the COVID-19 pandemic occurred and government agencies and companies had to support non-centralized workforce. And now in 2023, 2024, the average internet US speed is now over 130 megabits per second, and 97% of US adults now are on the internet. So those are the transformative changes I've seen throughout the years. And I hope to highlight them more as we work through our discussions and questions.
Great, thank you, Danielle. Fred, let's have you go ahead next, and then we'll follow with Bill.
Okay, great. Thanks, Bruce. Hi there, I'm Fred Gifford. I'm the Director of Mapping and Analytics at the National Democratic Redistricting Committee. So I'll tell you a little bit about that organization and tell you about my background. So at NDRC, we work to prevent gerrymandering of congressional and legislative maps nationwide. And as I assume most of you know, gerrymandering is the use of mapping to give political power to a group that is larger than its numbers. Turns out it's been done since the beginning of the formation of our country. And as you can imagine, with all the technological and data advances over the years, it's just become more powerful and more sophisticated than ever. So our group, we take a really broad look at it. It's not just mapping. We do electoral work. So we try and find politicians who will also support anti-gerrymandering efforts and support them. We do grassroots organizing. So we try and get people to attend meetings and write letters to the editor and that kind of thing, opposing gerrymandering and supporting things like redistricting commissions. We have a large legal team. It's a legal process. And so we fight in the courts against illegal mapping. And then a big part of what we do is also support the creation of nonpartisan redistricting commissions at the state level, essentially just trying to get politicians out of the room when the maps are being drawn, because that's really, in our view, the only way you're going to actually get to fair maps. And then the mapping team that I manage supports all those activities with a lot of analytics and map drawing. But my background is really broad. I've been doing GIS for a long, long time now, getting kind of long in the tooth. I've been doing it since the late 80s. And I have a really broad background. I've worked in the private sector, worked in local government, state government, a little bit in academia, back in the private sector. And then I've been in the nonprofit sector for about the last 10 years now. And I would say, I mean, the reason I bring that up is like one thing that all of those sectors have in common is that they all include significant use or creation of public data. I mean, that's just the foundation of it. And I'm sure, you know, most of you know that. You're wondering why I'm on this panel. I led the development of one of the first GIS online clearinghouses at the Montana State Library INRIS program back in the 90s. And when I left that program, I was hired by Lily Way, who founded Inside Idaho, as a contractor. So I've been here, well, I worked with Inside Idaho at the very beginning, and I remember when Bruce was hired. And so that's pretty great. I'm pretty sure he was like the second intern. He might have been the first intern, and now he's been there ever since, just kicking butt and doing a great job. And so that's actually really wonderful to see. I do want to talk a little bit about Lily. You know, Lily, she was in the library at the same time I was in the library in Montana and seeing the same things, that this wealth of data that really wasn't being utilized very well and could be utilized much better if it was broadly distributed. And so when the internet came along, well, the modern internet came along with web browsers, and it was really an aha moment for a lot of us who were trying to do data distribution. Lily saw that and just formed a vision of how she could use the internet to distribute data. And that was pretty transformational because, you know, back then, not all librarians were pro-internet. They kind of saw it as a little bit of a threat to them. And then they also knew for sure he's just rocking the boat. And but she very much, you know, had the vision of like, let's use this, use it to get the data out. And I remember her telling me, you know, her goal was to make data as accessible as books. And I think that she achieved that and really created a foundation that's been benefiting, you know, Idaho for decades for data distribution. So as far as like transformative things I've seen in my career, I mean, definitely the biggest thing has been, just as Danielle was saying, is the internet, essentially. You know, the internet, it just changed the whole world for data distribution. For those of you who weren't around pre-internet, it was pretty rough going getting the data we need to run our GISs. And I can remember being at NRS when, you know, this is pre-internet, when we first were able to get a CD writer. And we thought that was like the coolest thing ever. We could put like 600 megs of data on one disk, send it out. Of course, a lot of the disks got corrupted when we were trying to write them. It was a major pain. But it was a big technological innovation that, you know, we'd just gotten going and really kind of gotten it worked out when the internet came along, and it disappeared immediately because it just was no longer needed at all, really. And we switched over to full on, you know, internet clearinghouse type technology. And then that's, as you all know, that's just evolved to support not just data distribution, but services and many other things on the internet. I'd say one of the other foundational things that changed over my career was just the creation of the federal and state level coordinating bodies. I mean, that's proven to be very, very powerful. I'm not really in that world so much anymore and haven't been for 10 years or so, so I'm not going to speak to it too much, but I know that there's still very powerful groups that are doing incredibly good work. You know, the coordination and cost sharing, everything is just really moved along enormously, and it's very powerful. And so I guess maybe just reminding people that that wasn't always the case, and it's very powerful. I think the other really foundational change, it's not so much a change as it is just something that's happened and evolved, and that's the institutionalizing of open data policies. Because again, that wasn't the case at the beginning. I can remember many efforts where leaders of different government groups were trying to restrict access and sell data to recover costs. And you can kind of see why they were doing that, is because they knew the data was expensive. They wanted to, you know, be able to support that. And so they were trying to charge for it. Won't get into like all the reasons why that's probably not a great idea, but it's really been pushed back now. And so now, at least from my standpoint, I mean, it's just with a very few rare exceptions, data created by public governmental agencies is freely available. And I personally only know of one group that's charging absorbently for their data. And so that's been great. I think that's been really transformative. And I would say too, is that one thing that I noticed is like, again, when we were first getting going in the US and we were first building these clearinghouses, in Europe and the Scandinavian countries, they weren't doing what we were doing. They were trying to restrict access and charge for data. And they've now evolved in our direction. So in the last 10 years or so, those Scandinavian European countries have very much followed the model that all of us have developed here and are making their data freely available because they can see all the societal benefits that come from doing that. So I did want to talk about one specific data program that I'm very familiar with now. And so at NDRC and doing political mapping, we use the census data for the basis of all our mapping. And when you do redistricting, you draw legislative and congressional maps, they become legal documents. And it turns out the only way to legally describe those districts is by using census geography. And so that's what we do. When you see like legislation establishing a new congressional map, it's probably the most boring legislation you could ever imagine because it's lists of census counties, tracts, and blocks just stuck into legislation. That's how we do everything. And if you think about it really, in many ways, census data is like the first example of public collection of data in the US. I mean, the census is called for in the Constitution. It's the only data creation effort that I know of that's in the Constitution. And it's been done since 1790. And congressional maps, at least in some states, have been based on the census data ever since then. But as we all know, redistricting is really just a fraction of the benefit that's derived by this country from the census data. I mean, census data is used for transportation planning, public health, civil rights enforcement. It's used in the private sector to, cite the next In-N-Out burger and everything else. I mean, it's a very, very powerful database whose kind of peripheral uses have swamped its original intended use by far, no question about it. But that being said, there's it's not like it's all been rosy for census data by any means, and kind of the work goes on. A lot of you probably remember during the last census cycle, there was a big controversy over whether there would be a citizenship question on the census or not. There was a lot, again, probably a lot of you remember this issue of differential privacy and the technique of using statistics to kind of blur the data a little bit to help ensure anonymity for the census population. And then finally, there's just been a traditional, need for, there's just been undercounting of marginalized populations through multiple censuses now, and that needs to be addressed and is still being worked on. So even with this very oldest, I guess the point I'm trying to make is, even with this very oldest data collection effort, maybe the foundational data collection effort in this country, the work still goes on to make sure it's meeting its use needs and of the highest quality possible. So kind of to wrap up, from my standpoint, public access to geographic data is foundational to our democracy. And, it enhances our material well-being. And so I know that, that's not new to a lot of you. But it is kind of not well known to the general public. And so I do think it's my belief that it's kind of our job as GIS professionals to, get the word out and make sure that everyone understands that, it's in our best interest as GIS professionals, and it's in their best interest as the public to be advocates for, development and access of public geospatial data. So
Okay, thank you, Fred. Bill, let's get your introduction and your perspective.
Well, I'm Bill Reynolds. I'm with Nez Perce County. I've been doing GIS work there since 2000. Before that, I worked for a little while at Potlatch-Deltic, went to school here, worked at the city of Walla Walla, just doing all sorts of public works stuff there. Potlatch was more of, hey, where can we grow awesome trees at? And so we spent a lot of time finding soils and different characteristics that they wanted to own this piece of land or get rid of this land because it was either good or bad for growing trees. And then at the county, I got brought in for addressing. I'll probably talk on a few aspects of what Fred mentioned about census data and just some of the changes we've seen over the time. Census data was, a lot of it was for especially very rural areas of Idaho. That was kind of your local data, and it was horrible. It was hard to look at. It was hard to decipher. It was topologically correct, but spatially incorrect usually. And then besides that, usually a name or road name had changed in the 10 years. And so that had all kind of been a big pain in the neck. What we also found was that because that was such a big data store for our nation, many maps for many of the mapping companies, that was in everything they had. When Google Maps came out, that was like the worst thing on earth because it had all the wrong road names for the most part. For 20 years, I think my job has been to email Google Maps and get on their update list and say that road's name is still wrong, you know, from 20 years ago. That's where I really feel the same way about opening the data up. From the very beginning, everybody but our county assessor has been very good with letting me just give the data away. My feeling on that has always been is I'd rather the people that need this data have it and it's correct, it's authoritative, rather than them using something from the census or somebody they grabbed from somebody else with wrong road names, wrong addresses, wrong response areas, whatever it is. And so I've been very good at like, hey, whoever wants this, you got it for free. I've worked with our assessor. We give out the parcel data. We don't give out the parcel CAMA data. It's like the owner information. He is very sensitive about its release. In the 20 years too, what we've seen is that we went from standard 911 in our country, where you just dialed 911 and they picked up the phone and said, hey, who are you, where are you at, what kind of emergency, to enhanced 911, where your location information got to them and they could ask fewer questions, to where now we're going to next generation 911, where GIS is flat out the reason why it'll work. We need accurate data at all levels. We need accurate polygons. We need accurate points. We need every address to be mapped. And we really got to test that with this year's election as we were validating addresses for people that were registering to vote. And in the last 2 months, we've put in well over 200 addresses into our database, just because we didn't know that these people had a basement apartment, or somebody's living in a tent behind a house because the parents kicked them out, I guess. I don't know. But you just, whatever crazy scheme you can come up with for where people are living, we're trying to track that so that when you dial 911, you know, the right responder gets to the right place in the most effective time. What I've really seen for on the data side too is that ArcGIS Online, you know, this region I'd say is GIS poor, in that there's just not a lot of GIS people out there at the local level putting stuff out. There's a lot of great people working at county and city levels, maintaining and updating data. But in our recent project working with the state for Next Gen 911, many of the smaller counties still don't have GIS people. They're still using data that was collected 20 or 15 years ago that has not been updated once since that date. We went into dispatch centers, and it was really shocking to me where I'd go into our county or our city dispatch center in Lewiston, and the dispatchers are dispatching straight from the map, the GIS map that we provide. We'd go to these other counties, and they're like, well, we bring up Google Earth because it's better than the map we have. And they don't look, they only look at the map if they have to. And so that switch in Idaho is kind of coming along slowly. And I think that's just kind of our region too, is just, it's been a slow process of getting accurate data into our 911 centers, getting them to our planning and zoning people, getting them to emergency management. Because as we know, in an emergency, if we have a forest fire or whatnot, it gets to the county line, it stops because it knows it's a new jurisdiction. So that's one of the things we've discovered as well. And in overcoming that, one of the best things we had is, since we had that regional data this year, Angel, who's my colleague that I work with, she does all of our ArcGIS Online stuff. We were putting out maps for 3 different counties throughout fires this season. And in fact, when we had the strike teams come in from out of our region, we were able to dump the data on them. They had accurate data, they had accurate addresses, and it really made their experience of like, where do I find address points? You know, we were able just to hand it right to them, and they could jump in right on the fire and start putting together their plans for their next operational periods. Those are some of the things going on at the local level.
Okay, great. Thank you, everyone. That was a great look at the changes you've seen over your time. I think for this next section, we're going to go through some curated questions. We're going to try to look forward a little bit and see what your thoughts are on some of the new collaboration and technologies coming along. And probably we'll start with a question that's probably at the forefront of a lot of people's minds, revolving around artificial intelligence, and not just for GIS, but we'll put it to the panelists. How will artificial intelligence impact the quality, access, and use of geographic data? Does anybody want to go first, or we can go through the same order we did with the introductions? Danielle, you want to take first shot at that?
Sure.
Okay.
So, as a perpetual skeptic, I will start with basically, to me, what artificial intelligence impact will be very much remains to be seen. In the GIS realm, especially the remote sensing portion of it, machine learning has been a very common tool used by remote sensing and other GIS folks to create data, to maintain data, and to, of course, create and manipulate make new data sets, create better quality data sets. And machine learning is considered a subset of AI. It's basically kind of the first step towards a full AI. It's the part that's the algorithm that can take input and start learning. It just doesn't try to be a human like a full AI, basically. I am a bit concerned actually about especially the predominant use of AI in search engines and for filtering data. I actually can see that being a very possible impact on data access and data use. One of the big things or problems I see with AI is, again, you're creating a little bit of a black box. You don't know quite what it's thinking because it's supposed to be thinking like a human. So how is that search engine filtering data, determining what is the best data for the question that you are proposing? Humans like shortcuts, and sometimes they stop at the first available answer without asking whether it's the best. So I'm a little concerned about that. Maybe your access is limited to what is available because of either the AI that you're using, or you don't have a particular AI at your disposal. I can see it becoming in some ways a gateway, for better or for worse. Again, much remains to be seen. So those are my initial thoughts.
Excellent. Thank you, Danielle. Fred, what are your thoughts on artificial intelligence? How is it gonna, or do you see it potentially changing GIS data quality and access?
I do see it changing things. I guess I'd say just like Danielle, I'm a little skeptical just because I have also witnessed what's happened with machine learning and imagery for a long time, and that is, AI for sure. And the big thing I've seen there is it's just been overpromised many times. And so I've seen wild, speculation about the power of that when it just wasn't there. And so, I kind of like stopped paying attention for a while there after, because it's just like, okay, I've heard the hype. I kind of know what it can do. And I would have to say, like, when the large language models came on board, I mean, that was something different in my mind. But then also, before I talk about that a little bit, but we've also, in redistricting, we also use another kind of subset of AI called global search, where essentially we write these algorithms that draw tens of thousands of millions of possible maps using the census geography to see all the various combinations. And then that's like the best way we can really detect gerrymandering, is doing that. And so that's become very powerful as well. And both that global search and then local search is kind of a technique that's used to draw smaller number of more refined maps. So we're using that. It's being used already. I think with the large language models and where that's going, I do see it like intersecting with GIS in a lot of ways. One way is that, they build the foundational models for the large language models out of text. Well, academics are working on the GeoAI part of that, which is a foundational geospatial model. And I think that when those are merged together, that it's going to be really powerful. Because if you think about it, like what's in our GIS databases, that's all facts. So those are facts that can be verified and that can be used to help stop some of the hallucinating and other things that the large language models are doing, because they have, where this road is a fact on the ground. The fact that a road goes through this county and not through that county is a fact that can be derived from these models and can be used to refine them. And I think that they will be merged and geospatial be leveraged in that way. The other big thing I see is just like, one of the best use cases for the large language models right now is for coding and writing, essentially, it's not like they can write full programs, at least in my point of view, but they can write snippets of code very efficiently and very effectively. And I know people are using it as part of their workflow right now. Developers are using part of their workflow right now. Well, I think it's going to transfer down to just GIS analysis in general pretty quickly. And so there won't be anywhere near as much of the kind of command line or specific pointing at ArcGIS Pro interface, button by button, string together commands one at a time. It's going to be much more, give it a broad set of instructions, and then it's going to go execute that for you. And at least in my mind, I mean, if you look at ArcGIS Pro, it's become such an unwieldy, large thing at this point that I think the LLMs will help cut through that very effectively and make it where, just by consuming the documentation of ArcGIS Pro and then, helping people work through it in an efficient way, I think that's going to become very powerful. And then I guess finally, I do think it's getting back to data access a little bit. I mean, there's no question in my mind that all public data, which is most geospatial data in this country, or a lot of it, I don't know about most anymore, but a lot of it is going to be harvested by these companies. It's going to be harvested and leveraged in ways that none of us can predict. And so we just need to be keeping an eye out for that and make sure. And again, I think as GIS professionals, we have a little bit different role there. We have more of a role there to make sure that we're watching and then raising the red flags when we think inappropriate uses are happening with that data.
Excellent. Thank you, Fred. Bill, do you have perspective on AI from the county level and the work you do on a day-to-day basis?
Well, I think in a practical way, I could probably, in a couple ways, talk about kind of an emergency response. I think the thing is that much of the AI questions or decisions are going to be made still are going to involve a human element to making the final decision. I think one of the nice things about AI is that it's going to route things and give, maybe take decisions out of people's hands that don't need to really be made, because it's going to be sent right where it needs to go to. Especially from the perspective of when a 911 call comes in, the dispatchers may not even have to dispatch the officer because it's actually coming up on their mobile data terminals. They can be routed directly. They can self-dispatch to go to a car wreck or to go to some kind of incident. It may be as they're typing it into the CAD system, the CAD itself will be able to say, well, let's get the ambulance rolling without the dispatcher even having to call into a fire department to say, hey, we need a paramedics at this location. So I see that as a real benefit of streamlining those processes. For instance, I was in the dispatch area the other day. We were updating the maps. And the dispatcher was getting really frustrated trying to find the location of this lady calling in a 911 call. She was in shock, but she kept talking to everybody around her, but not the dispatcher. And he was trying where are you at? And she would be like, well, we were in a wreck over here. And he's like, you need to talk to me. And, if we did have the next gen system in, we'd be accurate to 30 meters of where they're at. Meanwhile, we had it was a sector on a phone call, and she kept mentioning Arby's. Well, there's 2 Arby's in Lewiston, so which one? You know, and AI would have been very helpful to, or next gen systems have been very helpful to know that. The other thing that's going to be great is being able to get, you know, like especially as we get more and more cameras throughout our community and our schools at intersections, you're going to be able to get situational awareness to those first responders as they're responding, rather than coming up on a scene, you know, hey, it was a hit and run, the driver went off in this direction. Well, maybe the responder then will come in from another direction to try and see if they see that, that person, the suspect. Or, you know, seeing an accident and going, hey, get paramedics, fire trucks rolling, we need more officers, we need, you know, investigation teams here. So in practical manners, I think, especially in communities where resources are limited, it's gonna help get the right resources to the right place in a quicker time. But it keeps falling back to is like you need accurate GIS data, otherwise there's still a lot of guesswork.
Right on, okay. Let's move on to a second question here before we get to the audience Q&A. Let's talk a little bit about collaboration for a minute and get your perspective there. You know, I mean, over the past 20, 25 years, we certainly have seen the citizen science or volunteer geographic information, you know, OpenStreetMap being one example, and other efforts where, you know, citizens collecting data and contributing to eyes on data quality and access. So what are your thoughts on some future directions of collaboration efforts out there in the GIS community and what we might see in the coming years? I'll just kind of open it up if any of the 3 of you want to take a stab at that. We don't have to go through everybody, but if somebody has thoughts on collaboration moving forward.
Well, I think I'll just say in general on fire response, during the fires recently, you know, we had evacuation notices go out to many communities in our area, and we did get a lot of feedback because we didn't have a map up. You know, we were evacuating certain areas, but people were saying, "Why, you know, why are you evacuating me? I don't even see the fire." And so, you know, in the first, you know, 24 to 72 hours of any kind of emergency, just brace yourself, you're on your own. That's really kind of the FEMA's mantra, is like, it's gonna take that long to get the resources established, in place, coordinating to kind of fight a fire. And that's kind of, I don't know if you guys were here this summer when we were having the fires down there by Juliet and Kendrick, that's exactly what was happening. And we were literally on the phone with the chief deputy from the sheriff's office, and he's yelling at me over the phone, and then he's like using some very colorful language because we were trying to get evacuation going, and the fire had jumped the river. And I thought he was actually in the line of the fire. And I'm like, oh, Mike, where you at? Where do we need to send some help? He's like, oh, I'm just watching it jump over the river, sorry. But it was changing literally in real time where we were gonna evacuate people from. And when we sent out the initial evacuation, we just got a flood of feedback of like, you idiots, there's no fire near me. But then as we were able to get real-time fire data, we were able to put out an evacuation map. We could show people where the fires were going, where wind directions were going. All of a sudden it calmed down, like, oh yeah, the fire's headed my way. And as we've seen in other fires, you know, 1 mile is not very far for a fire to travel and take out a community or homes. And that's exactly what happened during this event. And so kind of getting that real-time quality to our GIS data, it's challenging. And we get, when we're wrong, boy, do we hear it. But when we're right, they're like, well, you should have been right from the beginning, you know. It's like there's no thanks in any direction. So that's kind of my real-time kind of public interaction this summer with the good and bad data.
Okay. Danielle or Fred, do you have any thoughts on collaboration moving forward in the coming years and decades?
I would like just to kind of to build a little bit on some of what Bill said. I agree that real-time data is almost has become an expectation to some degree. And Bill is absolutely right. In GIS, if it works, nobody notices. When it doesn't, everybody else. And that is because a lot of the work that we do in GIS has very serious real-world consequences, including if you evacuate the wrong community. That is impactful on many, many levels. Hopefully you guessed at least on the other side and not on the side where people are actually in danger. But what I also see though is that kind of my reference to the cell phone, people also, part of the real-time data that I think that we're going to, as GIS people, need to work more on is that people have that real-time mobile device in their hand, either an Android or an iPhone, and we need to be able to tap into those in emergency situations and build infrastructure that allows us to do that. So that when we get the phone calls like from Mike, instead of Bill saying, hey, where are you? We know where he is. And we can adjust our evacuation maps because he's saying, hey, it's jumping over the river. We know he's a valid source. We know that information's good, and we know we have to adjust that evacuation order. Yeah, the person yelling at you says they don't see it from where they're standing, but you're saying, hey, but it's 1 mile away. And then you can send them the map showing the fire boundary in real time using many of the resources we have available. We're on the cusp of that, but there's still a lot of infrastructure that needs to be built in order to leverage all of those resources. And that is, infrastructure is expensive. Infrastructure is difficult when you have a low tax base, in particular. It is certainly something that throughout my career as a state employee, I've had to battle with that, is that how do you balance the things and the needs that you see in the future with the constant need to be extremely stingy with your dollars. Infrastructure and GIS data has never been cheap. GIS data was, in my opinion, some of the original big data, and it has only gotten bigger. And so it requires big things to manage it.
All right, thank you. Let's hold there on the curated part because I've only got through a couple questions and used up all the time already. But I want to give people an opportunity here, or I certainly have more questions. But give folks in the audience and online. Does somebody have a question that they want to pose to the panel related to data quality and collaboration here? Or any online questions that you have for the folks? We've got one over here in house, and then we'll come to the online.
Thank you all for coming today. So my question sort of is at the nexus of data availability, access, and sovereignty. So, I'm almost 40, but I remember the time of burning CDs and sharing data and not really having the internet. And as this, internet's kind of proliferated, we have cloud computing and the ability to share data in vast amounts and quality of data with each other. All of you work with sensitive data in some form, whether it's voter information or land ownership information, parcel ownership information, sensitive wildlife data, right? Natural resource data. What do you think are the challenges going forward in the future with cloud computing and sharing these sensitive data sets and having them hosted by, maybe it's ArcGIS Online, maybe it's Amazon Web Services, but giving these sensitive data sets to corporations or other entities to kind of hold for us that can then be maybe compromised or something like that? How can we walk this line of sharing and collaborating on data, but also retaining the privacy and the sovereignty that's required? Thank you.
Anybody want to speak to that?
I'll just speak a little bit on the Idaho code concerning like property information. Idaho code basically doesn't say anything about us not giving it out. It says we can't create a mailing list from it. And that's what our assessor's office is just paranoid about, is that it's going to come back on him that a mailing list was derived from this. Now, the government can create as many mailing, I give it to U of I give it to the state. They can make as many mailing lists as they want, but I can't give it to, Sonic so they can send out coupons to everybody, whatever they want. And that's what they're sensitive about. I think we're coming along. I wish that sometimes the legislation would kind of match what the reality of how this data is going to be used. And it's just, we're a state that likes to stand pat.
Others, Fred, you have thoughts there?
Yeah. I'll say, I mean, I do think that, well, personally, I just believe in right to privacy, and I think it's really important. I think where that intersects with, governmental data collection, that needs to be taken really seriously. I think we've done a pretty good job over the years, but there's still work to be done, just like I kind of mentioned with the census data, there's definitely work to be done. But also, where I think about it a lot more is kind of been, Daniel and Bill were kind of referring to, is like the data collection happening in our pockets every day, the GPS units in our cell phones, and what I call like volunteered geographic information. I mean, we're all data collecting units out there all the time. And I think it's a problem. I think it's a big problem that private companies, are the only ones who have control over that. And because they're doing things with it that benefit us, but they're also doing things that work against us as well. And I think it's our right to provide some guidance on the use of that personal data. And again, I think as GIS professionals, I think we are in a unique position to know kind of the power of that data, what appropriate uses are, what appropriate uses aren't, and to speak up about it.
Excellent. Okay. Other questions in the room or online? Anybody, thoughts? No, any online, Jaleesa? No online? Well, let me come back here, and if anybody has one, by all means, just, stand up, raise your hand, let me know. I've got a few more I'd like to talk about too, but I'm certainly happy for any online and any in the room. Let's go through just a couple more of these. In terms of this data quality issue, we've talked a little bit about, accessibility being opened up and the things that have come with that. And we need to be really cognizant of quality there. But what are some of the consequences? Assuming there are, areas for improvement, what do you see as still some of the stumbling blocks or consequences if we don't improve data quality and access more for the things we need? Anybody?
I think the biggest thing I see there is, and it's not necessarily quality as much as maintaining stewardships over this data. I don't know how many times the counties around us have hired companies to come in and collect data for them. And they get a grant or whatever it is, because these little tiny counties just don't have any money. They collect all this data. It's okay. And then they spend these tens of thousands of dollars on it. And then 5-10 years later, they're doing the same exact thing again to a different data model for a different software they just purchased. And it's exhausting to kind of watch this waste continue in striving for this quality data, when it's like you could have hired somebody or signed somebody or contract with somebody to maybe maintain that data for you, and you wouldn't be having to reinvent it every 5 to 10 years.
So one of our big hurdles there is you see them viewing this as a project where there's a beginning, middle, and an end, and then they're done. It's not a program that endures, but they go through this project cycle every X number of years and never assume like a stewardship and a business case in their unit.
It's
okay.
rampant. Yeah.
Okay. Other thoughts on that, Fred or Danielle? You good there? Oh, go ahead.
Well, I would point to what Bill talked about in the beginning about just the flow of data back and forth, up and down essentially, and being able to integrate locally created data into these more national data sets and things like that. I mean, I'd say we've made a lot of advancements on the technological fronts, but on the kind of the organizational fronts of how do we share that data? How could that data flow from one scale to another, from one place to another? There's still a lot. We're still in the infancy of that, I believe. And I think that's one of the areas where we just have the most to potentially gain by increasing that interaction and then having, large gains in the quality of the GIS data by essentially doing much more of a bottom-up approach.
Okay.
I think that's what Tim is for Wilma. I mean, that's what she's trying to do is get
The
this
Idaho
bottom.
map.
Yeah.
Okay. Well, let me ask you, shift gears a little bit. We still got 10 minutes left, but I wanted to talk about something we've worked on for decades and all been familiar with, and what might go into to that in the future, and that'd be metadata. So, Bill's leaving the room. So yeah, Federal Geographic Data Committee, FGDC's pushed metadata for years, and you can't have a data set without metadata. And I'm curious, in your experience over the years, or going forward, or right now, how useful is that to you? Do you think maybe just get AI to write it? You hate doing it. Where's metadata come into the data quality and access portion of what we're talking about?
I'd like to
Danielle,
take
you
that.
have thoughts? Yeah,
I
there you
do.
go.
I absolutely have thoughts on this. And you're absolutely right. To me, the conundrum is that everybody loves metadata when somebody else writes it and their data comes with it. We're terrible. Always have been, and always, I have yet to find the solution to that. I don't want to say always will be, because I struggle with that. And a little bit of that is that we're all pressed for time, and documentation is the last thing we think of. But it is, to me, it is a linchpin to our data sets. How can we expect people to use our data appropriately if we don't tell them what the data is and how it should be used appropriately? And there is also just I will say a general misunderstanding of what the data is. I mean, I once had somebody say to me, well, the data has to be right. It's in a database. Yeah, and all the managers are looking at their toes. You know exactly what I mean by that. There is an assumption of quality without documentation of how that quality was reached. Many of us work very, very hard to make excellent quality data, but again, you can't, if your data was collected using Landsat data, you're not going to be able to identify the fire hydrant on the corner. If you need to identify the fire hydrant on the corner, you have to use a different method. But sometimes when somebody finds the quote best available data, that's the data they have as the Landsat. And that leans into a lot of what Bill was referring to earlier about how, census was the best thing out there, but for his purposes, it was terrible. So how do we bridge that gap with limited resources and limited infrastructure and ability? It's a constant battle. And metadata helps us make those decisions, though. It helps us reinforce that. When you go to your county commissioner and say, census is the best data I have, but I cannot tell you where the fire hydrant is, so it cannot be used for E911. There's your reinforcement. And without metadata, you can't even talk that talk.
Fred or Bill, any thoughts on metadata?
I have this discussion with Angel. I mean, she's my succession plan, so I'm showing her everything, but I should be capturing it better. One of the ways we've quasi done it a little bit is just, hey, our authoritative data sets are here, everything else is over here. The problem is with everything else is over here is historical decisions and maybe some very important land use decisions have been made using some of that data. And if you're not tracking that, you might be in violation of state code. So, you can't just throw it away either. You have to keep it for those kinds of things. And putting metadata, in fact, on the way up here, Angel and I were talking about this exactly. It's like, how do we better track our information? Do we have like a README doc in every single ArcPro folder we have that says, this is why the data was created, this is what it was used for? so we have metadata for just the project, not just the data or whatever decision was being made.
Right. Okay.
So, yeah.
Okay.
I'm still sorry, Bruce, I'm not good at it.
That's okay. Fred, you want to take one last crack before we move on to the last question?
Yeah, I would just say from my observation, it's kind of shocking how primitive the tools still are for doing metadata. They should be way easier. And I can imagine, I'm sure all of us can imagine like lots and lots of ways where the software tools could make it easier so it's not such a burden. And you're only asking that person to put in the things that really can only come from them, because that will always be the case. And I don't know, Bruce, I mean, you've seen over the years, I mean, there's been like different focus on metadata tools and all of that, but it's definitely seems like it's fallen way out of favor now. And that's too bad, because I do kind of put it on the software developers. I mean, it needs to be part of what a professional GIS tool is. It needs to help with the metadata, do lineage tracking, things like that, and just like lift that burden a little bit, and then just keep the metadata tied to the data no matter what, just different data structures that don't let that chain be broken.
Right. Okay. All right, so we've got 5 minutes left. Barring any other questions, I'll just kind of bring it maybe full circle and ask you guys, from each of your perspectives, if there were one thing that you hope people in the audience today do as a result of our conversation, other than go create metadata, what would it be? Or write tools that make it easier to capture metadata. Now, what's something that you'd like folks to take away here, each of you, in the last 5 minutes from this session and going forward?
I'll go ahead and jump in first.
Right,
it's not kind of necessarily one thing, but I just lump it under situational awareness. Be people that are aware of what's going around you. Like, I was told years ago, read at least 2 newspapers a day, and I try to go look at, the local newspaper, maybe another news source. Just be aware of current events. You don't know when your boss or somebody's going to come and talk to you about something, and if you're always kind of a numbskull about what's going on in the world, they're going to be like, yeah, don't give them anything. Because I really feel like us that are in GIS, there's a geographic component to being collaborative. And part of that's just being aware of what's going on in our world. And it helps us to become good problem solvers. And that's probably the biggest hindrance I also see for us, is we become good problem solvers, so our bosses keep coming to us and saying, hey, by the way, solve this problem. It's a blessing and a curse, because you're doing great things many times, and sometimes you're like, why am I still doing this at 9 o'clock tonight? And that's what I'd say is like trying to find that balance, be a problem solver, and be situationally aware of what's going on in your organization and your community, and just help out.
Okay. Fred, Danielle, thoughts on what you want folks to take away? Fred first there.
Sure. I'd say, from my point of view, it's what I said in my presentation. Just, I think that, the most important thing that's happened over the course of the last 25 years is this institutionalization of freely sharing data and ensuring that it's publicly accessible. And I do think I believe that like our institutions, a lot of them are going to be stress tested here in the upcoming years, and that, again, as a community, we know the most about how important it's been to have access to this data, and that the work goes on to ensure that that's the case for, the next generation of GIS professionals. So I think we just need to, continue to work on it, advocate for what we think is best, and hopefully it'll all work out.
All right. Danielle, final thoughts on what you'd like to see folks take away from this session?
Well, it's funny when you said the one thing I couldn't say was make metadata, because that was exactly what my number one was. But also, I would say get involved. GIS has always been a community. Again, collaboration was the name of our game, even just making the original GIS data sets, getting the original topographic maps scanned. It's always been a collaborative community, and It can only continue to be that way if people remain in, continue to be involved. Become involved in some of these larger organizations. I'm glad to see the folks that are here today at GIS Day, but take a look at the work that our Wilma Roberts and the GIO is doing with the National Map and the IGCEC, and being involved in technical working groups, and trying to address some of these questions of what is the best available data? What does that even mean? How do we get better data? How do we make it work as best we can for the most people possible? How do we guarantee access to that freely, or that taxpayer data, which should be public, in my opinion? I think I'll just say that outright. How do we change the minds of those who are using public funds to make data who do not share that opinion? But those are all things that are done by a village, not by an individual. So I would recommend everyone please do pick your organization and become part of the community.
Okay, thank you. I think that's perfect summary there. So that's going to conclude our panel discussion. Thank you to Danielle, to Fred, and Bill. Let's all give them a hand for coming out. Thank you very much for taking the time to share your thoughts with us today. We appreciate it. Take good care, Fred and Danielle. And we'll take a short break here for 10 minutes before we start short talks, everyone.
Thanks, Fred and Danielle.
How's everybody doing? Thank you for joining us and celebrating this wondrous holiday and making it through to the very last session of the day. So that's pretty impressive, and we should give everybody the round of a hand who's still here. I'm Evan Williamson from Digital Infrastructure Librarian over at the library here at University of Idaho. And one thing that I just wanted to do is make sure we give a hand to Bruce Godfrey, who's pulled this event together for as long as we've had GIS Day at University of Idaho, and does a great job and builds these connections, this networking, and this community that everybody's been talking about. So let's give Bruce a big hand. And then I get to introduce our next set of speakers. We have 5 more short talks to wrap out the afternoon. And we're going to start with our online presenters here. And we've got Karsten, and I'm just going to let you go ahead and take it away.
Okay, thanks. Just a test. Can everybody hear me?
Yeah, we hear you good.
Okay, nice. So let's jump in. We have a short 10 minutes. So I want to take it away for mixing up this, as we heard in the last panel discussion, using public funding, should be used in a good way. So it's not only about the data, but I have been a consultant and been working with open source GIS for the last 15 years off and on. And I want to show some of this was mostly involves web mapping. You can see here if you're interested in any of this and want to send me a question, I take that to the beginning here. You can go to my website, terragis.net, and find my contact info there. So I'm based out of Seattle, and the reason I'm here is because I recently acquired a company, Greenwood Maps, that has been involved in a similar way as I do. I've been mostly working with web maps based on 3 components. I will show those in a second. And Greenwood Maps and Rich Greenwood, he has been running for over 20 years these map servers for many counties. 3 of them are in Idaho, so Fremont, Idaho, Clark County, and Custer County are the 3 in Idaho. And then you see most of Wyoming is also running map servers, and they're all based on open source software. So I want to take away first that all this software is supported by a nonprofit. So the development of software is scattered around the world by many people in many countries, just like the OpenStreetMap that was mentioned in the last panel discussion. And we have many of these software projects, and 3 of them are the basis of what I will show you. And I happen also to be of the regional chapter. It's called the Cascadia chapter of open source. We are the chapter for the OSGeo here in the Cascadia region. And I happen to be the volunteer president, a job that nobody wants. But actually today on GIS Day, we also have our monthly meeting, and I will present actually a poster map. But let's jump into that. So if you look at one of these maps, just wanted to highlight the power of open source GIS, and this is a good way to save public funds because they're really low cost and blazingly fast. So what is this based on? What can you do here? Basically, it's a parcel view, just like any county has, and you can identify parcels, get information. And I don't want to drill much into this. You can look at that yourself. But I just wanted to highlight that this is a very powerful tool. There's not only one vendor that can do that, but many. And then open source is a good way to leverage the software because anything that somebody invests in the software will be shared, not only around your county, your city, your state, the United States, but the world. So basically any investment here and around the world, I mean, unfortunately, US is one of the countries in the world that is pretty much behind in using open source. But just wanted to show what this can do. You could look at property details and so on. You can search. It's a full text search. You could say it goes to a Postgres database, and then you find anybody with name Smith. You can click on that, and here you are. Similarly, you can just punch in any of the property information and run there. There's some tools you could do, like what every regular web map has that you know from other vendors. There's extension for this. There's an agricultural tool. There is a treasurer's extension that I run for several treasurers in Wyoming, where you can online pay property taxes. There is a tax assessor's extension where you log in. This is a public-facing website, and there are several other things. So I just wanted to highlight what capabilities this has. You also can show this in different maps, so you can run to a Google map or at an OpenStreetMap background. So just want to highlight that. But there's some other things I wanted to highlight. Here you can have look at some of these counties, but I wanted to come back and say, what is this based on? So there is one tool, from this OSGeo Foundation, or well, not from the OSGeo Foundation, but the OSGeo Foundation supports the development and as a board of people that decide what is done with funding that's collected. And basically what is MapServer? MapServer is a cartography engine, just like ArcGIS Server, and it can give you back data, legends, feature request infos, web map services, and such things. So that's the first piece of software that is built on. The second piece of software is, some people might know this, some might know JavaScript library is the front end in the browser. OpenLayers is one of them, very powerful. And then the last is an extension to the Postgres database. It's called PostGIS. Basically, it is the name is kind of the agenda. It means it's after GIS. So basically, you put your GIS capabilities into the database. It has hundreds, or depending on how you installed, thousands of functions you can calculate. The geometries are just in a column. You can have multiple in one table, and you can run distances, intersects, whatever you know from your GIS system. So don't want to dwell on too long, but basically these are, 3 projects that are supported by this foundation. If you look down here, my mouse is now over MapServer, and like the first thing I showed you, and then it has a page about a MapServer. This is also the foundation that supports, one of the most prominent desktop GIS systems, very powerful QGIS. And QGIS at the moment has about 1,200 extensions, as we call it, or we call it plugins in QGIS, because they can be programmed just like in ArcGIS. There's ArcPy, there's QPy, and that's why thousands of people around the globe are programming that. Some of the counties I am managing the data for actually using QGIS for their day-to-day work. So let's take a break from these county servers. Let's look at something a little bit more different. So this is another interface on the web mapping platform I've been developing with a couple of people. And you're looking at West Africa. So what is this for? This is for an agricultural project. And we kind of built a raster calculator using soil data. At 250 meters, we have information for the entirety of Africa derived from point data, and they interpolated that thing. And I'm a soil scientist by background, so basically this information is pretty much wrong if you interpolate it for the whole continent, but the best we have. So this project is a research project, and you can calculate. I just want to show one of the tools here. With this specific tool, it's a guide to calculate suitability for different field crops. And you can draw in an area of interest. I just take the south of Benin, and I will do a raster calculation. I can select here. It's more complicated than that. I just want to show what this can do. So I want to calculate the suitability for the field crop of maize. And then the input is whoever has some natural resource background, you see soil pH, precipitation in the growing season, available water in the soil, and organic matter in the soil. And let's just jump. There is a scientific model behind this from the Food and Agriculture Organization of the United Nations. And then you can run this calculation and see, very dangerous to do this live, but basically you see you get a suitability classification from your input. And on the left-hand side, we can see the legend. So from red, not suitable, over orange, marginally suitable, to very green, very suitable. So basically that is an approach how you can use open source GIS building on the server. We're using libraries that are also used in ArcGIS, like GDAL, and you get an image back. So with this, do I still have a couple of minutes, or are we done with the 10 minutes? Just want to check in with you.
You have 1 minute.
You have 1 minute. Just want to, pinpoint that this is a good option for WebGIS. I'm running this for many organizations around the globe. It's running in 4 continents. It has multiple languages available. It's very easy, configurable, and cost effective because the base software is all supported by the community. So there's no cost in licensing. So of course there is the same cost for producing data as anywhere else or having people involved, but just want to encourage you to take a look at open source GIS. I've been teaching open source GIS for many years around the world for many organizations, and contact me if you have any more interest. Thanks for your attention.
Thank you so much. All right, thank you so much. Our next up is Pam Bond, and we'll turn it up over to her on Zoom there.
I'll share my screen here. We'll get started. Okay, are you all being able to see my screen?
We're currently seeing your interface of PowerPoint.
Checking. Still look good?
Now that looks perfect, and we can hear you well. Thank you.
All right, thanks. Hi, my name is Pam Bond. I have been doing GIS in Idaho for like 15 years. My background is in mostly state and local government, but a couple of years ago, I started working for myself, but still work with state and local government just as a consultant and a contractor. And today I just wanted to talk a little bit about a project that I'm working for the state of Idaho on next generation and why our next generation of GISers are needed for 911. So some of you have probably already seen that there's a lot of opportunity when it comes to using GIS in the public safety sector. You can be doing something as simple as maintaining data for computer-aided dispatch, and this kind of ties in a little bit with Next Generation 911. Crime analysis and prevention, fire, EMS, optimization and monitoring, emergency and disaster response, real-time situational awareness. There is a ton of options there, but I'm going to talk a little bit about Next Generation 911 specifically. So I think Bill Reynolds probably touched a little bit on Next Generation. So this is the next iteration of our 911 system that our entire country and Canada are moving to. So I started working as a contractor for the state of Idaho in the fall of 2002, and me and 3 other contractors are working with every county in the state. And we basically started from scratch in Idaho, other than Bill's territory in Nez Perce County and a little bit in Bonneville County. You know, as a state, we're really now starting to move towards preparing geospatial data for that new system. And one of the big things with this new system is instead of relying on kind of these tabular lookup tables called the master street address guy or the alley table, I've heard of that alley location indicator or something. Anyways, it's old technology. It's tied to landlines, and who calls from a landline anymore? Most people don't even have a landline. And so there's been a lot of like, I don't know, duct tape and barbed wire that's been used to kind of rig up add-on stuff so that we can get potentially the location of somebody from a mobile call and things like that. But really what needs to happen is we just need to roll to Next Generation 911. And so those tabular lookups for addresses and roads are going to be replaced with geospatial data. So we're talking about things like road center lines, site structure address points, the boundary of a PSAP boundary. This is a public safety answering point. This is the boundary of kind of a dispatch center's location, their jurisdiction, emergency service boundaries like fire districts, ambulance districts, and then the provisioning boundary. You know, what's the boundary of the data that you're maintaining? So it is akin to maintaining GIS data for something like a dispatch CAD, but it's in a very specific format. And the reason I bring this up is we have been talking about Next Generation 9. Bill probably has been talking about Next Generation 911 for like 10 years in Idaho. Bill started talking about it before I even really cared, like knew. So it's fun, you know, it's like, it's so amazing to see this as kind of something that's kicking off in the state of Idaho. And one of the reasons I bring this up is I especially want to be talking to students or people who are thinking about like what skills to have or potential for using their skills. Getting into this could be a really beneficial thing for you. Skills needed, attention to detail. So we're trying to make the best available data possible. We want the most accurate picture with our GIS data of what's true on the ground. Creating and validating topological rules. So knowing how not just what topology is, but how to actually use it. Creating and using validation rules. So again, this should be through topologies. This could be through attribute rules or scripts or setting up models, something like that to kind of help make this a little bit easier. And honestly, one of the big things is soft skills. You need to be a GIS person who's a good communicator. You are easy to collaborate with and you're patient because one thing I'm finding is there's like a lot of communication and relationship building that is tied into this, especially like even if you were just working for a particular city or a particular county, you know, you need to make sure that you're talking to people in different departments because even though they might not see how you all tie together in the different departments, GIS can be kind of the glue. You know, it's like you might have an addressing authority that creates an address, but when they're creating those addresses, maybe somebody from public safety should be sitting on those meetings to ensure like, yeah, we could get a fire engine there, or yeah, that's a good name. We don't have a street that's called that name, things like that. So soft skills are really important. So why consider this? Like I mentioned, it's an international initiative. Every state in our country and Canada is in some way trying to transition to next generation 911. Planning for this started way back in like the early 2000s, maybe even before then. There are still states that are transitioning to next generation 911, and data maintenance is going to be perpetual. I see these things and I'm just like, job security. If you have the skills to help maintain this data, there's going to be opportunities for you. If it's with a city, a state, there are now large private companies that are working on things that are tied to this as well. So there's lots of opportunities for jobs out there. So just to give you an idea of this, I pulled some graphics from 911.gov. This here shows like like each state self-reports what % of your GIS data has been converted from legacy. So like using the old tabular data to next generation 911. And as you can see, there aren't a lot of yellows, which are 100%. So again, lots of opportunity here. And same with what level of maturity does your state fall in the category of GIS? If it's not, let's see, orange, then there's still work that needs to be done. So again, opportunity here. So I'm talking about this mostly because I kind of ignored this for a long time. So I'm like, oh, this doesn't relate to me. I don't work on public safety GIS data. But now that I am working on it, I'm seeing where there's a lot of like crossover skills. There's a lot of things happening in GIS that are like, big bells, whistles, we're talking about AI, we're talking about doing awesome things with like remote sensing technologies that are available. But if you're really good at just maintaining good, clean data, there's going to be job security here. So there's definitely opportunity, job security, transferable skills. Like if you learn how to maintain good data for something like this, you can transfer that to whatever's everybody wants to have good, clean data. And we like to say you'll be saving lives with GIS. So that's all I have for you today. Just wanted to put that out there, get that seed in people's minds. I appreciate your time. And again, my name is Pam Bond. I'm the owner of GoWest Geospatial Services and working with the state of Idaho on this project.
Thank you so much. All right, we're going to transition to our in-person short talkers here. We have got 3 more for us today. And we're starting off with Sam Jenkins.
Hi, my name's Sam Jenkins. I am the GIS administrator at the city of Pullman. I am also the new secretary of the Northwest GIS Users Group, and it's that which I'd like to talk to you about today. Northwest GIS Users Group is a community of GIS professionals. The purpose of the group is for training. We've talked about that today. Exchange of knowledge and exchange of data techniques, geospatial techniques. Exchange of data. Exchange of data is probably a little de-emphasized, and we talked about that again today and about how all our GIS has been platformed and connected by services, but keep that in mind. And we're also heavily integrated with Esri because most of the users in our community use that software. And so Esri has been gracious in the support in sending people to the group and representing at the group and providing a lot of technical support in the group. But I would also like to mention that we do have a community of open source and non-Esri software users too. So I would like to make sure that that is out there too. The way the Northwest GIS Users Group enacts those goals, that mission, is primarily, but not exclusively, to have a user conference. The user conference happens annually in about September, but it'll depend where we go and what's available. You can see from our map here that it moves around the Pacific and inland Northwest, so there's always somewhere that the conference is going to happen nearby, and there's always somewhere that you can travel to that you probably haven't been to yet if you were to attend a conference. Of course, our conferences involve presentations, training, pre-conference course training and post-conference course training. We have map and app gallery and poster competitions for GIS professionals and for students. But the large focus of our conference, at least in the last couple of years, has been on collaboration. And so at our conference, we have a number of networking opportunities, special interest group discussion topics, which get conference goers into smaller groups so they can discuss, meet new people, and come away with specific questions that are relevant to them. And we've also been experimenting in the last couple of years with much more collaborative sessions, which, like the special interest groups, get everyone in the conference session involved, talking and participating, asking questions and providing solutions to the community. The other thing we do is build social community. Northwest GIS Users Group hosts a social meetup at the Esri User Conference, which occurs in San Diego. It's open to all, but anyone from Pacific and Inland Northwest, of course, is encouraged to go. We're supported by a number of sponsors. And also we've been working on hosting a social meetup at the Esri Dev Summit too, if that's happened to be where you were. We provide and host and provide opportunities to do training, again, online throughout the year and in person preceding and after our conference as well. In fact, we've got Python courses offered by David Howes, which starting in early December. If that's something that's interests you, there's an online course. Take a look at our events page. You'll be able to see more details about that there. Of course, we have a newsletter. Communication is a big part of the collaboration. So we have a monthly newsletter. If you were to sign up to Northwest GIS Users Group, we have a forum, which is there to enable people to ask and get questions answered by a community of professional users. It's a big site for job announcements, and there are a number of listservs that have Pacific and Inland Northwest job announcements. And of course, we have social media too. We also, as a group, have decided to offer mentoring and experience opportunities. And I think this is a really important focus that we're starting to build into our group. Always, we're looking for volunteers to work on the board of directors of this group, and that is a great way to meet people and get an in-depth and appreciation of the variety of GIS professional work that's being done in the region. Actually, last year we started a mentorship experience, which is for a student, which is to sit on the board of directors, and that is a one-year experience to encourage new students to get into the GIS community and learn how these groups can be developed. We have a grants program, and you can apply for grants if you go to the organization website and click on that grants tab. And of course, we like to sponsor GIS events around the country, like GIS Day events, for example. Around the Pacific Northwest. Sure. And the other important thing which we're starting to build too, build into our community is resources, geospatial resources and collaboration opportunities. I'll give you two examples. We have at our website, we have a little free library of GIS job descriptions. This little free library came about because someone in Northwest GIS Users Group needed to write a GIS job description, needed to convince their bosses that we needed to add a position. And it was really important that we know what a GIS job looks like in the Pacific Northwest. And so this little free library is a Google survey site. If you have, if you're interested in knowing what a GIS job description looks like around the Pacific and Inland Northwest, you can go to this library, you can grab job descriptions and compare them to the job that you're thinking of creating. Of course, if you have a GIS job description, you should go to our website and you should post it up there so that you can help build a community. Everyone knows, everyone has access to those resources. The second one I want to talk about is something that we started just this last conference, and I'm working with a group of people from the Northwest GIS Users Conference to build a GIS business system integration resource database. A lot of the community in the Northwest GIS are county and local government and state government, which run their GIS, but need their GIS to integrate with a lot of other different business systems, like accounting systems, like asset management systems. And so this working group is designed to build that resource so that when you decide as a GIS organization that you need to go in and interact with another information system, we can have a list of resources of organizations who have experience integrating with all the different types of all the different types of integrations and different softwares. And you can go in and you can find a resource where you can talk to another GIS professional who's done the integration that you're looking at and get advice on whether it's a good experience or a poor experience, which you should maybe reconsider. So I talked to you about the group that I'm involved in, Northwest GIS Users Group, but I don't want to necessarily suggest that you must join that. The take-home message that I have is there are many GIS organizations around the region. You should definitely join one of them. WGISA is the Washington GIS Association. Or URISA, I don't know how to say that. That's Oregon URISA. That's a URISA affiliated organization, as is the Northern Rockies URISA. URISA is another GIS community that you can be involved in. Locally, there's a regional GIS meeting which occurs approximately quarterly. And Angela Vanderpass, who's the GIS administrator at the City of Lewiston, organized that. She said, if you're interested in attending a local GIS meeting, definitely give her an email and she'd be happy to let you know when the next one is occurring. There's also a GIS Users of the Palouse, which meets every second Tuesday of the month in Moscow and Pullman. It's a small group, but it's people who are interested in GIS, interested in geography, just chatting about the maps they're making and the work they're doing. There's some links there if you want to join, if you want to find us on a Facebook group or a LinkedIn group. That is all I have to say. If there are no other questions about Northwest GIS or GIS communities in general, no, I do have one more thing. My take-home message is, of course, if you're a student, I cannot recommend, or a young GIS professional, I cannot recommend highly enough getting involved in these communities that will help you build your career. If you're an established, a mid-career or a senior GIS professional, make sure you're involved in one of these societies or these groups so that you can help young people grow and build a better GIS community. Thanks. How much time? How much time do I have?
You're done.
Okay, I'm done. Excellent. That's what I want to know. Thanks very much.
You did. Thank you so much. We really appreciate it, and going back to that community theme that we've been hearing about is really wonderful. All right, we have Amanda Wood and Susan Spalinger.
My name is Amanda Wood. Susan is online. Will we be able to get her audio? She should be online. If we have any questions for her, she'll chime in. I'm an environmental scientist at Alta Science and Engineering. I've been there maybe about 6 months. So this project that I'm going to go over today the startup was really quick. We had to find something that worked in the field pretty quickly. So I'll let you get the slides. She's on? Okay. Okay. I'm going to go over the suite of software we use to collect field data for the CDA lake sampling project. The main objective of the project was to determine the levels of contamination with heavy metals. If you're not familiar with the area, there was some silver mining to the east, and there was some heavy metal contamination in the lake and Spokane River. So that's monitored pretty closely with all the public access sites for recreation. This part of the project that I'm going over today was the field sampling portion. And then I'll kind of go over where that went with the data we collected and what we're going to do from here. I'm excited to go through this project with the theme of today. I started GIS 25 years ago using ArcPad. I don't know if anyone's familiar with field data collection using ArcPad. That was ESRI's first mobile application. I worked for ESRI in tech support for many years, supporting mobile applications. And seeing how far it's come from that to what we're able to do online with field maps and Experience Builder and ArcGIS Online is really helpful for this specific type of fieldwork. The DEQ, the Department of Environmental Quality with Idaho, contracted Alta to sample 32 sites around Coeur d'Alene Lake. We had to delineate the areas that we're going to sample, determine if they were wet sediment, dry sediment, and then we also did water sampling. The requirement was something called ISM, incremental sample method, and there's some specific requirements to do with that. When the field lead for this project came to me asking if this is something that I could help with GIS, it doesn't really get more spatial than that. So I hadn't used the tools that I'm going to go over today, but I knew there had to be something in the hundreds of tools in GIS that would work for this. Our process, like I said, we had to delineate the study areas. They're called decision units. From there, we created the sample points. It had to be 30 subsample points or 40. If it was over 9 acres, you had to do 40 points. So a subsample we took 30 samples within the given decision unit, and then you combine them into one sample that represents the entire decision unit. Then from there, we were able to use what we collected in field maps, directly imported into Experience Builder so that the project managers could see kind of in real time what we were collecting out in the field, and QA and QC as we were collecting the data. This is just showing how we delineated the decision units. We used field maps to walk some of the areas we couldn't get to, so we had to use Google Maps to delineate them from in-house. Occasionally, we tweaked our field maps, delineated polygons after the fact, depending on what we saw in the imagery. And then with these decision units, we used ArcGIS Pro desktop to create the sample points. There's a tool in Pro called Create Spatial Sample Locations, and it works beautifully for creating 30 points within each polygon. The method we used was spatial distributed in a given polygon. That gave us 30 sample locations in each polygon, depending on the size of the polygon, determined how far apart the random sample points were. These are the forms used in field maps. There's nothing really special about these forms, but there's kind of a theme of quality data that I think everyone here appreciates. When you can set up domains and subtypes, for field data collection, it saves so much work for the people in-house that have to QA, QC the data. So we took a lot of time with this and setting up all the fields that needed to be created and the data to be collected so that it was mostly automated drop-downs. There wasn't a lot of, the field crew didn't have to type in a lot of information. They had a few selections to make, and then they did enter the end of the sample ID was really the only thing they had to enter. For the sample point locations, that was just related to the sample polygon. So all the information that was stored in the polygon layer transferred to the point data set. And then from there, this was fed into a map and experience builder so that the project managers in-house could QA and QC as the data was coming in. We could see each time someone collected a sample and they changed the form from not sampled to yes. We could see that dynamically in the map as the points changed colors as they clicked finish for the sample. This is just a little closer view of how many samples it really takes to do an area. I think these areas were a couple acres. They weren't that large, but there's a lot of data to be captured. This particular site had upland soil, dry sediment, and wet sediment. So that's 90 sample points for just one sample site. And we did 32 sites. So quite a bit of data was captured. A couple of things that we learned from this project. We used Samsung tablets. They had an integrated GPS. The accuracy was, because we created the sample points ahead of time, we didn't need high accuracy to get a point created in the field. We were just navigating to the point. They were not accurate when in some of the tree canopy areas, and they were kind of pinging all over the place. So it was a little bit difficult in those areas to get right on the point where we wanted to take the sample. That was kind of, we did have a EOS Aero GPS, external GPS unit that we've used with the tablets before, and that helps a lot to get you that sub-centimeter or sub-meter accuracy. The other lesson learned with this one, we didn't generate the offline maps right away. We had a lot of connectivity. We were lucky enough to have a lot of connectivity in the field to where we didn't need to generate offline maps. There were a couple areas that we needed to go offline, and we had trouble on occasion generating the offline maps at the last minute. There was some lag in internet connectivity. And then the other, we generated all the sample points as separate data sets as we were going through each day, each site. We created new sample points. I think a better way to do it would have been to create one master point data set and just use that instead of configuring each point data set every time we loaded it into field maps. And that's all I've got for today. If you have any questions.
Okay. All right, thank you so much for that. And we have just one more speaker. And I'm just gonna let you go.
Hi, I'm Gabrielle Fieber. I'm a PhD student here in the Environmental Science Department and also part of the Deep Soil Ecotron project. And today I'm going to present on deep soil carbon at risk. So soil is a large carbon store, and over 70% of this carbon is located below 20 centimeters. but changes in climate can put these carbon stores at risk. And so the goal of this research is to determine areas where carbon is the most at risk. And this is a soil organic carbon map that goes down to 2 meters. And the important part of this is it only goes down to 2 meters, but soil goes a lot deeper than that. So how much carbon is below this? And so to quantify deep soil carbon risks, first I created an estimate of deep or understudied soil in the United States. And this is because soil depth is important in understanding the total amount of soil carbon that is in an area. And then I will create an index to assess soil carbon vulnerability. And this helps us understand which carbon stocks are at risk. But to understand deep soil carbon risk, we have to define what deep soil even is. And so what I found is there's really no broad consensus. It's driven by specific research goals and interests. And so some scientists say it's as shallow as 20 centimeters, while others say it can be as deep as 20 meters. And so this research will help explore the definition of deep soil with the data available. And for the soil carbon work, I'm using the definition of any depth below the plant rooting zone. To find understudied soil, I use 2 main data sets. The first is modeled data based on global data sets of soil profiles, drilling records, and inferred data, and this is looking at depth to bedrock and likelihood of bedrock in the top 2 meters. So depth to bedrock is you have the top of the soil and it's all the way down to where you hit a continual bedrock layer. And then the likelihood of bedrock in the top 2 meters, if you see that dotted line that goes across, it's the likelihood that you will encounter bedrock in that zone. And then the second data set that I used is the soil profiles that were collected by the NRCS to look at the deepest depths studied and the density of the studied soil across the US. And so using these 2 data sets, I can find out how much soil has been explored versus how much soil there even is. And so this is just a brief overview of some of the data. So most soil in the US goes down to at least 20 meters or an average of 20 meters. The top 2 meters of soil is not likely to contain bedrock. And most soil samples have only been taken to 1.5 meters deep. And so the amount of soil that has been studied is a lot shallower than the amount that there is. And so then I created an equation to quantify the understudied depth. And so this is based on the likelihood of bedrock in the top 2 meters, the depth to bedrock, and the max lower depth studied. And so the likelihood of bedrock is important because if you're trying to be able to study this soil and you're likely to have bedrock in the top 2 meters, then you're not going to have soil that you can study. And additionally, the top 2 meters is a lot more accurate of a model because there's more data to model it off of. And so if the likelihood of bedrock in the top 2 meters is less than 65%, then the understudied depth is depth to bedrock minus the max lower depth studied. If the likelihood of bedrock is between 65 and 80%, then the understudied depth is 200 centimeters minus the max lower depth studied. And if the likelihood of bedrock is greater than 80%, then the understudied depth is 100 centimeters minus the max lower depth studied. And then there are also model errors, and this is where the depth to bedrock was smaller than the max lower depth studied. And this means that scientists were able to find soil deeper than where it said there was continual bedrock. And so here are the results of the understudied soil map. And so first, there's a lot of understudied soil in the United States, and it also correlates with soil depth. And so there's a lot of deep soil in the Great Plains region, as well as the Southwest. Additionally, if you look at the density of the points that have been studied, the interior West, Alaska, Hawaii, Puerto Rico, the US Virgin Islands, and Guam are very understudied. Additionally, model errors are concentrated in California, Texas, Florida, Alaska. And so the main point of this work is it helps us see that deep soil is dependent on location and where there even is deep soil, as well as soil that has not been studied before. And again, for the soil carbon work, the deep soil will be defined by the depth below the rooting zone. So now we get to deep soil carbon and vulnerability. So deeper soil holds this unknown amount of carbon, and carbon is at risk due to climate change. And so the goal again is to identify areas that are vulnerable to this carbon loss. And plant vegetation, land use, and soil type are all threats to this carbon loss. And so again, this is the soil organic carbon map, but this time I've highlighted where there's deep soil. And this means that in these areas, there is more soil carbon there than what is shown on this map. So next I get into soil carbon vulnerability. Well, what is vulnerability? So vulnerability is deviation from the norm, and it threatens the status quo. And so for soil carbon vulnerability, we have to think of what is the threat. And so this threat is the release of soil carbon to the atmosphere. And so here's a schematic that shows first rooting depth and how stored carbon is going to be stored based on how deep the roots are. And so you're going to have a lot more carbon turnover when you have deeper roots, and the carbon is going to be stored a lot deeper. And also these roots allow for flow paths for water and nutrients and carbon to get down into the soil. And so the next step is creating the vulnerability index. And there's a limited amount of data sets available, but with the ones that were available, these are the 4 that made the most sense. And so first, you have total soil organic carbon. This is the amount of carbon that is stored in the soil. And so if you have more carbon that's stored in the soil, then you have a greater risk of losing this carbon. Additionally, deep soil carbon. So this is the amount of carbon that's stored in deeper soil or below the rooting zone. And so if these roots end up growing deeper, then they can release some of this stored carbon that's below the rooting zone. And so rooting depth is also important. First, it allows water and nutrients and carbon to be transported into the soil. And it also can help release some of that soil carbon that's stored. And lastly, carbon turnover. This is the time that carbon is stored in the soil, and it indicates carbon stability. And so you're going to have a greater turnover if you have these deeper roots, and more carbon will be released. And so they all work together to help define soil carbon vulnerability. And so putting it all together, first I identified understudied or deep soil. Then I compiled the data necessary for vulnerability. And the last step is running an index. And that will allow me to create a map, kind of like this one, that shows spatially how the carbon vulnerability for the US. And this will help answer the question of what makes an area vulnerable to carbon loss. So if you want to find out more, please scan the QR code up there, and it gives more information on the understudied soil work. And thank you.
All right, thank you for hanging to the end of this session. And let's just give one more round of applause to all our short talkers this afternoon. It was really great. And we do have a few minutes, so actually I'd like to open it to questions if anyone had questions for this group of speakers. We still have Pam Bond over on Zoom, and we have all the other folks in the room still. So was there any questions that people wanted to ask for this group of short talkers? Don't be shy. I'll let you think about that for a few more minutes. I'm just going to do a little bit of housekeeping here before we leave. One of the great things that we saw, so many resources shared today. If you go over to the GIS Day schedule that you've been sent, if you registered, we have a repository page we'll take the recordings from today, we'll take all of the slides that people have shared to us, and those will be available on our repository page. There'll be all those resources for you to go explore and click on those links and see these really cool projects that people have shared. So do check back in a week or two. Wait, next week is Thanksgiving, so check back in like 2 weeks to see all of that. And it's an ongoing resource that we can share out there. And other than that, if no one is piping in on questions, then I think just one big more final round of applause, and we'll say Happy GIS Day one more time, and have a good afternoon.